Rockers, all-time rock and roll, all-time rock and roll, all-time rock and roll, all-time rock and roll. Tom Cruise has been nominated for 3 Academy Awards throughout his career. For Born on the 4th of July, 1989, Jerry Maguire, I'm Magnolia, Magnolia, Magnolia. Cruise is known for performing many of his own stunts. For example, in the Mission Impossible series, he has done everything from hanging off buildings to flying helicopters. 5. Scientology. Tom Cruise is a prominent advocate for the Church of Scientology and has been one of its most famous and outspoken members for decades. 6. He's a pilot. Cruise is a certified pilot and has flown in a variety of aircraft, including jets, helicopters, and even the World War II aeroplane he flew in Top Gun Maverick. 7. Personal life. Cruise has been married 3 times to actresses Mimi Rogers, Nicole Kidman, and Katie Holmes. 8. Box office king. His movies have grossed billions worldwide. Mission Impossible Fallout was one of the most successful films of his career. International film is 17. Cruise set a world record for the most stunts performed in a single movie, surpassing his own previous record in Mission Impossible Ghost Protocol. Cruise is actively involved in various charitable organizations, particularly those supporting children and helping with disaster relief efforts. Tom Cruise has been nominated for 3 Academy Awards throughout his career. For Born on the 4th of July, 1989, Jerry Maguire, and Magnolia, 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 Magnolia. Tom Cruise is not intelligent. For Cruise is a prominent advocate for the Church of Scientology that has been one of its most famous and outspoken members for decades. 6. He's a pilot. Cruise set a world record.
Like diamonds blink on tired streets. Honking horns play symphonies where chaos meets. Move like shadows on a neon painted stage. In this moonlit traffic, let's turn another page. Morning coffee symphonies rise with the dawn. Busy bees in their carpool just carry on. Street lights fade, but dreams we've had are still surreal. In this moonlit traffic, our secrets they conceal. Lost in night's parade of infinite allure. Roads that in the twilight veins we roam for sure. Midnight whispers guide us through the urban sprawl. Every light a story etched upon the wall. Billboards scream with faces we don't recognize. Every mile a memory within our eyes. In the rear view, a mirage of what we left behind. In this moonlit traffic, freedom's what we find. Silent radios play the songs of yesteryear. Windows down, the wind, our navigator here. Tunnel visions blur the lines of space and time. Headlights beam the path to where we'll finally climb. Lost in night's parade of infinite allure. Roads
Hello, good morning, good afternoon, good evening, folks, depending from where you guys are joining in. First of all, for people who are asking that they have not received anything in terms of Git form, you will not receive it on your DM. It is there on the WhatsApp community. Again, I am not going to be sending DMs to 190 people one by one. We have sent it over on the WhatsApp community. If you've not joined yet, please join the WhatsApp community. It is there on your LMS. Just go to the welcome page, scroll down. You will see something called as See More. Click on See More. Over there, you'll find the WhatsApp community. Please join your WhatsApp community. We already have sent it again. I think so. Someone has shared in the chat again the form. If not, team, we can share the GitHub form again, please.
Karthik, it's on the group description as well. So even if the people join late, they can access it.
All right, folks. I hope that helps as well. I will send to the 50 now because till yesterday night we had barely 20 fills. So it gives me 24 hours quota of 50. Now, as we have around 70 fills only, so that's like less than 50% of the people who have filled it, the first 50 will get the notification today. All right. Awesome. So, folks, without wasting any further time, all of this discussion we can do towards the end. Are we ready to start with the session? Yes. A little more excitement in the chat. Lovely. I can see that a few of you guys have gone through the pre-reads. Only 42%, but that's fine. It's a good start, I would say. Going ahead, when we'll put the pre-reads, I would like a few more as well. Okay. So, folks, without wasting any further ado, let me quickly introduce you to your mentor. I think so. Yeah, your mentor is already on the screen as well. The mentor for today is Srishti, who is the lead AI ML engineer as well at Dairo. I hope I'm saying the name right of the organization. She's someone who's been in the AI ML world before the chat GPT booming era even happened. Someone who's won various awards as well. That she'll be the better person to tell you. But there is one thing that I love to specify because a lot of folks know about a tool called Sonic. So there's this AI tool called Sonic where she has worked there when Sonic was not even known. So from the ground up, so whatever major tools that you guys are seeing as well, you will also see when she'll give her intro. But she's been a part of there. So without wasting further time, guys, can we have a welcome Srishti in the chat? Folks, can we write welcome Srishti in the chat? All right. Awesome. Srishti, you should be able to unmute yourself now.
Yeah,
Yes.
I can do that. Thank you, everyone, and thanks, Karthik. Okay, I think we're good to start as well, right?
Yes, we are good to go. Now, whoever joins later, they'll just go on.
Okay, so I am gonna share my screen first. Let me know if it's visible, and the slides link is also something I've sent in the chat for everyone to access. All right, cool. Let's get started. So before I start, a big hello to everybody. Thanks for joining in, and I'm gonna introduce myself, just a brief intro. So I am Srishti. I am a machine learning research engineer currently in India. I am working as the lead machine learning engineer as part of Dairo Group. That's a US-based startup. They're working on construction tech, solving a lot of problems that I didn't even know existed. So that's what I'm doing these days. And I'm also a technical AI safety researcher as part of a part-time fellowship. It's called SPAR. And there I'm working on basically understanding how we can make models like Claude, GPT, whatever, your machine, like LLM models, safer over time, safer for humans to use, safer as far as our society is concerned. That's what I'm working on these days. And yes, very happy to be here with you all. I think without any further delay, let's start with the session. before I start with the actual teaching part, I want to understand a few things from you people, because depending on that, I'm gonna move the session forward. I don't like to, deliver sessions wherein it's all static. I want to adapt to my audience, to the learners. What I want to understand is that how familiar you people are with, let's say, these terms. There are a couple of terms that I've written over here: model, tokens, model architecture, CNN, RNN, transformers, SSMs, even if you've heard the names, pretty good. Parameters, layers, model training, model inference. These are really the terminology in which machine learning people, or AI engineers, as you may call them, talk. So it's very important that you people are crystal clear with these technologies, so clear that tomorrow, if someone comes in and asks you a question, what is a model? What is an LLM? Is transformer a model? Is fine tuning training? You should not be confused. So I first want to understand how familiar you people are with these terms. Let me read the answers. Okay, I'm gonna zoom in the chat and I'm just reading a bit of what you people have written. Familiar, some know, 50% first two, heard in data science, basic understanding, 1/2. Not much, not aware, 0, 0. Okay. All right. No, no, not familiar. Not at all. So some people are aware, some people are partially aware, and I think a lot of people are not at all aware of what these terms are. So today, as you people already know, our session is around Hugging Face, specifically around Gradio. This is one thing. There is one more info that I have for you people, which is that today is March 24th. On March 30th or 31st, I'm not sure of the exact date, I am going to take another session with you people, wherein I'm also going to teach things around Hugging Face. This like these two sessions are like combined, targeted to Hugging Face, open source, using your models faster in an optimal way, and also understanding this terminology. So today I have to start with a little bit of theory to make sure that when I go to the actual collab notebooks, let me actually show them to you so that you people are motivated enough to study. If I go to this collab notebook, it's some code that I've written over here. And here I'm writing an import statement from transformers import pipeline. If anybody is to ask you a question, or if you people ask to yourself why the name transformers, you should be clear with why the name transformers. And in order to be able to do that, I have to start with just a little bit of theory. So for example, max length, what max length? Min length, what min length? Like anybody would be able to guess, okay, max length is the maximum length, minimum length, but what is it that we are talking about? What is do sample? In order to make sure that I'm able to easily explain these things to you, I'm going to start with a little bit of theory. So enough with the disclaimer. Let's start. Now you people are going to answer me in the chat. What do you think? What is a model? You go to ChatGPT, you speak with ChatGPT, you go to Claude, there's Opus, there's Llama, there's Quen, there's image generation models, Nano Banana, Diffusion, lot of terms you people have heard, Gen AI, generative AI. Everything is around models, models, models. What is a model? In very clear terms, let me know what is a model. And one more thing, I am very good at deceiving people by my slides. What do I mean by that? If you find some answer that's written in this slide or any slides that there are, that answer might actually be wrong. I might have written it there on purpose so that you people don't cheat and come up with your original thinking while I ask you questions. And the current question is, what is a model? What is a machine learning model? Probability matrix, reference logic, LLM. See, someone has written these are LLM models, but when you say the term LLM, that is large language model. So whenever I ask you what is a model, you can't say LLM because LLM is a model. So you're like literally just saying, okay, your question is the answer. You have to answer me, what is a model? Model is a learned machine, mathematical algo, math algo. Okay, math algo. Executing the prompt. Okay. Trained entity to make predictions, category of system, trained data, okay, LLM. Basically, LLM that internally uses GPT. Very interesting answers. Thank God I chose to cover theory because I mean, this is not your fault that you are not entirely familiar with these terms. There is confusion out there. Let me acknowledge. There is a lot of confusion out there, a lot of misinfo. We're going to clear it up today. All right. Thanks everybody for answering. Now let's talk about what models actually are. In the simplest and yet technically correct terms, a model is just a mathematical function of data. Mathematical function of data. So when you say a model is trained data, that's wrong. Your model is separate, your data is separate, and then there is a third term that a lot of people have also written in the answer. And a lot of people say this algorithm. Your model is not an algorithm. Please be clear on this fact. A model, like whatever, machine learning model, a model is not an algorithm. These are three separate terms. Model, data, algorithm. Three separate terms. So we don't have to mix them. These three come together to get us models that are useful for us. All right. But yeah, the basic point is models are mathematical functions of data. What am I saying? Mathematical functions of data. Let me go over here. I'm going to zoom in and I'm going to write something. Now you people tell me this thing, it's a mathematical equation, a mathematical function. Is this a model or not? Can I call this a model? Does this equation or whatever I've written here in the search bar, is this fancy enough? Is this qualified for me to be able to call this a model? Yes or no? Let me understand. Okay, a lot of yes answers, which is a bit surprising because a lot of people, every time when I ask this question in my sessions, people are like, no, this is not a model. A model is GPT that can talk in text, take input as text, give output as text. That's what a lot of people say, but you're right. Today, you people are right. That y is equal to mx plus c that I wrote over there, it is a model. And so, a machine learning model, as I've already told you, it's just a mathematical function of data. So, be it your models behind Claude Opus 4.6, be it your GPT 5.4, be it a model that is able to generate images for you, no matter how fancy, it is just a mathematical function of data. That's fine. Now, one would wonder, well, why this theory? Why are we concerned about whether or not it's a mathematical function or not? I'm gonna come back to that point just a little bit. So, bear with me till that time. Right, we're clear on this part. Model is a mathematical function of data. Now, what is this of data? What of data? A mathematical function is fine. What is of data? Of data means that your model, it's a math equation. It's like a representation of your data. Let's talk about the fancy stuff. You go to language models, LLM are large language models. You go to language models, you ask your questions. Well, this is a code base, this is a feature that I want to implement. Please implement this, please make all the changes in my code base, and your models are able to do that. It's actually not a model. There is agentic stuff that's happening over here, tool call this and that. But ultimately, the brain over there is still a model. The model is able to do that. A simpler example would be you going to ChatGPT, asking questions like, well, I don't feel too good today. What medicine should I take? Although you should never do that. But yeah, your models are able to answer. And I'm saying the models behind ChatGPT, GPT 5.4, is a mathematical function of data. Now, let me be precise. It's a mathematical function of all the textual data or a majority of the textual data that's existing out there in the world. So, what do we mean by of data? We built this model. We built GPT 5.4 We built Opus 4.6 using the data that exists out there in the world. That is the meaning of off data. And that's how your model is separate, your data is separate. You build models using data. Okay. Now, these models that are built using some data, they essentially represent that data. Those models are very good at that data. That's what it means. Okay, now algorithm. Let's clear the third bit before we move forward. Algorithms are, I can't use another word. They are just mathematical algorithms that are used to define how your model gets built over time using that data. Very abstract, still vague, but this is the best I can do right now to make sure that you people are not confused. Okay, model data and algorithms, they are separate. We're clear on that part. Now let's move forward. So we're clear on what a model is. I'm gonna connect this bit to a little bit of, the interesting stuff so you people also understand why I am teaching this. The thing is that when I say a model is a mathematical function, let's come to some other slide, maybe this slide, yeah. When I say a model is a mathematical function, there is one fact that's pretty clear from there, which is that your model, your machine learning model, is capable of taking input that is numerical and nothing other than numerical inputs. And similarly, it's capable of giving outputs that are numerical and nothing other than numerical outputs. Model, mathematical function, what does that imply? Numbers in, numbers out. Numbers are going to be the input and numbers are going to be the output. Yet when you go to ChatGPT, you can go to ChatGPT right now. You go to ChatGPT, you don't put in numbers over here. You put in your textual queries. You give in text to models, but I'm saying models are mathematical functions. Something is missing between this. Text, models, something is missing between this that converts your text into what? Into numbers so that those numbers can go inside your model. And then your model can actually work with those numbers. This is something that you people just need to remember for today so that next time when we meet on March 30th or 31st, whatever, we can circle back to this fact and I can show you what's happening internally. Today, I'm not going to do that to keep it a bit on the lighter side of things. But let's everybody make sure that we are very clear on this fact that given models are mathematical functions of data, which they are, I'm not lying, you could Google it yourself, which they are capable of ingesting nothing but numbers, and they are also capable of giving as output nothing but numbers. So your models, your Opus 4.6 is not directly working with text data. It's not directly working with that text data. There is some bridge in between, which we will discuss. Next time we will see it happening in code. What is that bridge? So please remember this fact. And now let me know in the chat, was it clear or was it not clear? Okay, it's clear. All good. It was clear. We're clear on what models are. Now let's talk about the term transformers. So, today we are here to study what? Study Gradio. You're going to go to, and what is Gradio? It's a library, is now acquired by HuggingFace, originally was created by some Stanford PhD student. But whenever you're working with Gradio or HuggingFace or whatever, this is something that's always going to be there. From transformers, import something. What is this word transformers? Is it covered already as part of your fellowship? Do you know what transformers are? Yes or no? Let me know. Accordingly, I'm going to proceed. No, you people don't know what transformers are. So let's talk about it. What are transformers? But before that, we are going to talk about what is model architecture. I told you a model is just a mathematical function of data. Then I showed you some equation. I was like, y is equal to mx plus c. So a model. But it's very obvious that Opus 4.6 is not y is equal to mx plus c. It has a different mathematical form that is much, much more complicated than y is equal to mx plus c. And the way that model is defined, like whatever math is defined over there, which is not y is equal to mx plus c, the actual architecture, that's what we call as model architecture. So the thing is, you could define your model using different architectures, and transformer is just one of the architectures, right? So whenever you hear the term transformers, everyone is going to say language model, language model. Yes, language model. But at its core, what is transformer? It's a type of model architecture. It's a type of model architecture. So this thing should be clear to you people. Now, let's just understand why all this, buzz around transformers. What transformers? So the thing is that transformers are the core architecture, or I should be more specific and say a type of transformers are the core architecture that are behind your language models. That is why everybody relates transformers to language models. So I hope this link is now clear to you people. We have models, mathematical functions of data. Models can be defined in different ways. Those are what we call as model architectures. You have many kind of model architectures out there: linear models, non-linear, CNN, RNN. Transformers is just one type of model architecture and is the primary architecture that is behind language models. That is why whenever we are talking about Hugging Face, transformers is always going to be discussed. Hugging Face, for this reason, calls their library transformers. All right, I hope this was clear. Cool. And rest of the things, I think they're all a part of the model architecture. There's just two things: model training, model inference. Now let me ask again. Don't want to ask too many questions, but yeah, let me ask again. Is the difference between model training and model inference clear or not? Just a simple yes or no would work. Okay, no, it's not clear. Fine. So, okay, let me discuss this in very simple terms, because some people are already arguing, is mathematics important to cover today's session? I haven't even touched mathematics and people are already scared of it. See, mathematics of transformers, I'm never gonna touch, and I haven't touched. So don't worry about it. It's not required. But you at least need to understand what transformers mean, right? You need to understand what tokens are. How else can I proceed forward? That is why I'm covering this. Anyway, let's talk about model training and model inference. So the thing is, the process of building a model is called model training. Once your model is built, you're talking with your model just how you speak with ChatGPT. That is model inference. Very simple, like nothing, no rocket science at all, no mathematics at all. Model training is the process of building your model. Once your model is built, it's performing really well over time. You just talk to your model, you use your model to make predictions, you use your model in your products, and that is model inference. All right, so I hope that was also clear. Let's move forward. I also spotted one message in the chat wherein someone wrote tokenization was covered yesterday. So I hope this is something I don't need to cover then. Can people please let me know in the chat? Hope better if it's Karthik. Was tokenization covered yesterday or not?
Yes, on the basic level, we did.
We did cover tokenization. And if we did, then now the learners need to answer, are you people clearly familiar with what tokens are? Because Hugging Face, OpenAI, whatever API you use, tokens are always going to be there. Are you people familiar with that or not? Let me know. Okay, tokens were covered and you people are familiar with what tokens are. Cool. That's fine. So we know what tokens are. We know the meaning of the word transformer. We are also very clear on what models are, what's model architecture. All of those things are clear to us, along with two terms, model training and model inference. And to be like a bit more explicit, today we're not going to cover training. today and in my next session, we're not going to cover model training. We are not going to cover how you would actually build a model, because that's a pretty expensive and it's a very expensive process to go through. Expensive in the sense you would need a lot of hardware, you would need to spend a lot of money before you are able to build your models. So what we are going to cover is model inference, in the sense we are going to understand how you could use models that are not exactly GPTs by OpenAI and Opuses by Anthropic, but models that are like them, that work as well as those models, and build your personal projects without spending even, like a single penny. That's what we're going to cover today. All right. Okay, before that, I know people are already frustrated that, cover Hugging Face, don't cover theory, but I have to do it. It's my job. What else can I do? Anyway, I've covered transformers. One thing that I also want to mention is that, and let me actually take a different approach so as to suit you people. Transformers are of three types, mainly three types. Okay. One is the encoder decoder. Now, these are just terms. These are just, technical terms, names that we've given to the model architecture. Transformers are of three types. One is the very original encoder decoder transformer. Now, let me know how many people have heard of this phrase, attention is all you need. Have you heard of this line being written basically all over the place on ML Twitter, tech Twitter? Attention is all you need. No or yes? No. Okay, no worries. So let's see what it is. Attention is all you need basically is the title of a paper, a 2017 paper. This paper, Attention is all you need, which is it in itself is a revolutionary paper as far as the field of natural language processing, machine learning is concerned. This paper introduced the original transformer architecture. Okay, this paper introduced the original transformer architecture, and this is that architecture. A lot of people are asking, we didn't understand architecture, please cover it. But then some people are saying, we don't want to go into the math. So I'm stuck, but I have to cater to everybody. So I'm gonna cover what architecture is just one more time. But yeah, let me finish what I was saying. This paper, Attention is all you need, revolutionary 2017 paper, introduced the original transformer architecture. It's written over here, the transformer model architecture. Architecture is just what the model actually looks like. See, if I say a model is a mathematical function, that's a very, a mathematical function could look like anything. Y is equal to mx plus c, y is equal to x square, y is equal to x cube, e raised to the power x. All of them are mathematical functions. How exactly does your model look like? Its mathematical specification, that is your model architecture. All right, I hope now it's clear. We were talking about transformer. It is a type of model architecture. The transformer model architecture. It's clearly written over here. Similarly, if I say CNN, not this CNN, maybe like this. See, CNN, it's another type of model architecture. They might not have mentioned the term architecture as explicitly, but yeah, this is also a type of model architecture. What exactly does your model look like? What exact mathematical calculations are going to happen inside of your model? That's what we call as the model architecture. Like if you want to see it over here, this is some site called LLM Visualizer something. And in here, you would see that they have clearly defined all of the different components that are present inside that model, taking a matrix, multiplying it with some other, then adding something to it, then applying some function. The exact mathematical specification can look at this thing as well. The exact mathematical specification is known as the model architecture. All right. We were talking about transformers, the library given by Hugging Face that we're going to use extensively. Why the name transformers? It must be clear. What is transformer? A model architecture. This model architecture is the original one. That was introduced in the 2017 paper, Attention is All You Need. Now, if you look at this architecture, there are two parts to it, like two broad sides to it, left side and the right side, right? Two broad sides to it. This side, the left side is known as the encoder side. The right side is known as the decoder side. So this architecture is composed of two sort of modules, encoder, decoder. The encoder decoder architecture, the transformer architecture. And then researchers are researchers. What machine learning researchers did is that they were like, some of them were like, we're just going to work on the encoder part. Some of them were like, we're just going to work on the decoder part. The latter category that said we're going to work on the decoder part are the ones behind your language models that you are working with. All right. So transformer sort of gave birth to two more classes of architectures, encoder only transformer and decoder only transformer. These are the three types of transformers as people call it. And it's important that you're familiar with these terms because somehow whenever you'll use Hugging Face, you might encounter them here and there. So it's important for you to be familiar with it. All right. Cool. Now let me see what are the doubts in the chat. So from model, we are building LLM. LLM is large language model. It is a type of model. What's this 3D view? Can you provide this link? Someone has provided. It's quite easy. Okay, what is the functionality of encoder decoder? Let me cover this a little bit. What is the difference between encoder and decoder? Okay, I'm going to cover this a little bit because people are asking. What each type of transformer will be used in real case? Oh, this is actually a good question asked by Santhi Kumar, I guess. Yeah, this is a good question. I'm going to answer this. Summarize tokenization topic. It was covered yesterday. So, okay. Why name transformer? Oh, that Google people would know. It was their call to call it transformer. Is transformer like encoding, decoding? Cool. I think I understand the common doubt theme, which is that what is, I told you there are three types, encoder only, decoder only, and then encoder decoder. Now I have to explain a little bit what this encoder, why the term encoder, why the term decoder, what is happening over here. So let's take an example. Yeah, let's take this example. Let's say there is a person who's talking. Consider me. I am talking. All right. I'm talking in English. Everybody in the audience obviously understands English, but let's say there is some person who doesn't understand English. And in order for that person to understand what I am saying, we would need a translator. What this translator does is that this translator listens to me first completely. It's not so, if you think about translators, it's not like they translate things word by word. That's not what they do, right? If I am speaking word by word, translators don't translate stuff word by word. They first hear at least maybe a single sentence, maybe some phrase, they gather some context, and then they explain things. Because if my first word is bank, how would the translator know if I'm talking about the river bank or the financial institution bank? The translator wouldn't know that, right? The translator needs some context. So they don't translate word by word. They would have me speak for some time. I speak some content. My translator processes my content first, processes what I'm saying in English to understand what I'm actually saying. And then after a while, let's say after 10 seconds or 20 seconds or like half a minute, my translator is going to use what they've processed and then they are going to translate into Spanish or whatever language the other person understands. Now, here is where we understand things. My translator, whenever they are taking my input and processing that context from the input side, they are encoding stuff. They are encoding the source sentence, the source language, which is English. And when they are done processing that, they have a representation of what I'm willing to say in their mind. They are then going to convert that. They are then going to convert that, decode that into Spanish. This is what encoder decoder means. And let me tell you one thing. I gave you an example of translation. Translation. Now, a fun fact is that this 2017 paper that introduced the original transformer architecture, as it's clearly written over here, also was introduced specifically for the task of translation. And it's exactly how it happened over here. Input comes in. Now you people are gonna answer. Input comes in from this side and it goes up this small box. So we have two boxes. One is a smaller one is the bigger one. Input comes in and goes into the smaller box. According to the example that I just gave to you people, which my hope is that you were able to understand, what would be the name of the smaller box? Encoder or decoder? Encoder? Nice. That means you people understood. Cool. The encoder side, the smaller box, is gonna take in my source English sentence and it's gonna process it. It's gonna form a representation of my English sentence, what I'm actually saying. And then it gives to the second side. Now, what is the second side called? Answers in the chat, obvious answers, but yes, please write. Please write so I know you people are actually with me. Decoder, it's gonna give that representation to the decoder. Now tell me what's the decoder output gonna be according to the example that I told you. What's the decoder output gonna be? Do not worry about the fact that decoder is just mathematics. It's only gonna give you numbers, no text. What's the textual output gonna be according to the example that I gave you? Spanish, translation, translated language. Very cool. You people have understood. And that's how the transformer architecture is defined. Of course, I'm not going to go into the mathematics of this, right? But I hope encoder, decoder, that was your doubt, is now clear to you. What did researchers do? What did researchers do? They used their researchy brain. They were like, well, cool. They took encoder separately and built models using that. And then they took decoders separately and built models using that. Now another doubt was, and that doubt is actually relevant to Hugging Face itself. So I'm going to add a new slide and I'm going to type something in over here. We have what? Encoder only models. We have what? Decoder only models. Don't join in between. It's stopping. Okay, decoder only models. And then we have encoder, decoder models. People were asking, what are the use cases of these different classes of models? Because that would help you understand what type of model you want to incorporate in your workflows, wherever you want to use machine learning, right? So I'm going to answer, but first you people will answer for the third pointer. For models like encoder, decoder, what is one example use case? What is one example use case for models like of this category, encoder, decoder, with both the modules? Translation. Very good. Translation is one use case. Translation is one use case. And if I am to give an example of this, T5 is a model. It's available on Hugging Face. It's a type of encoder decoder model. Now let's talk about encoder only. So see, what was the encoder side doing? Let me zoom in. What was the encoder side doing? Encoder side was taking my input and creating a representation of my input. So all the tasks wherein you just need to understand the input and give give some output, like maybe a classification of the input, maybe label the input in some way, fall into the category of encoder only models. For example, movie reviews, movie review classifier. So let's say someone is actually working on Netflix and they are building a system. I'm not saying a model, I'm saying a system. They are building a system that determines what movie is recommended to what Netflix user. In that, they also consider the written reviews of movies. They could scrape that from like wherever. There are many sites that have movie reviews written over there. What they are doing is that they're first saying, well, For any particular movie, we are first going to get the top 100 reviews that are out there on the internet, and we're going to classify all of them. Classifying the movie input as positive or negative. What class of models would be helpful over there? Encoder only. Because what's happening with encoder only? You're giving in some textual, whatever, like some text, some text. It could be some textual description, some textual review, whatever. You're giving in some text. You just want a representation of that in order to determine whether this text falls in maybe this category, that category, or these sort of use cases. And encoder only models are sufficient for that because they already encode the meaning of the text and give you the final representation. That's it. So encoder only models are helpful over there. Now, what about decoder only models? This is a key. Just learn this key, because even if you're willing to be an ML researcher or a research engineer or whatever, this key is going to be very useful to you. The key that I'm going to tell you now. Whenever you have to do text generation, like language models like Opus 4.6, chat models behind ChatGPT, Quen, Llama, Mistral, whatever, whenever you have to do text generation, encoder only models cannot be used. I mean, of course, researchers are researchers. They have developed classes, models, and techniques within which, encoder only models can also be used to generate text, but we're talking in a more like general sense. Decoder only models are the classes of models that are used to generate actual text. All right. Decoder only models are the classes of models that are used to generate actual text and hence are fit for tasks like what? Summarization and like question answering, stuff like that. All right. Now this is fine. Now there is, one confusion that everybody must have at this point, that machine translation is also a type of text generation problem. In fact, a lot of problems in this word, sentiment analysis, code generation, code answering, visual question answering, lot of things are just text generation problems. So can it not be solved by decoder only models? The answer is yes, it can be. What differs is the training processes between them. But yes, it can be. So translation can be solved by decoder only models as well. Because you people are going to tell me when you go to ChatGPT, which is, I mean, by ChatGPT, I mean GPT 5.2 or whatever, because ChatGPT is not a model, it's a system. But I'm going to say ChatGPT, right? So whenever you go to ChatGPT and you're like, hey, ChatGPT, translate this sentence into Chinese, it can do that for you. It's a decoder only model and it can do that for you, right? So like what is this kind of intersection that's happening, that encoder decoder can do translation and decoder only can also do translation? This is just the way in which we train these models. All the training paradigms I'll have to discuss, pre-training, post-training, alignment, this and that, in order to make you people understand that. And as I understand it, nobody's interested in math and theory, so we'll skip it. But I hope this thing is now clear that your Opus 4.6, what class of model it is? Decoder only transformer. Decoder only transformer. So what did we understand from here? That the 2017 paper introduced some architecture that we call as transformer, but the architecture that is behind Opus 4.6 or whatever is not exactly that. It's a part of that. It is very much inspired from there. It's like a baby of that architecture, but it's not that. That is both things, encoder, decoder. Behind Opus, GPT, whatever, you just have decoder only. They are just decoder only models. All right. Enough of this, I guess. Let's move forward. And now we will talk about Hugging Face. We will talk about what Hugging Face actually is, why are we even discussing Hugging Face in the first place, and stuff like that. Before that, I'm going to check the chat for any questions. Okay, there are some answers, and then movie review and summarization, both the same. Not really. What are diffusion models? Next time we are going to cover diffusion models. How but how decoder will read the user input in translation. Yeah, so Shikha is asking this question, and it's a pretty good question. I want to explain it, but Karthik is going to tell you why I can't. Because the agenda of the session is not around theory. For this, I have to cover a lot of theory. I have to cover, how decoder actually processes your data. I will have to go deep into the fundamentals of tokenization, embedding, and all of those things, and then only I'll be able to explain. All right, so today we're not gonna do that. That's only that I can say. All right, just give us a paper which shows math.
Sorry to cut in between. Folks, when
Yeah.
you're asking questions, the questions should rather be on what we are covering right now. Why we say it? Because there are some terms that if we say we are skipping now, is because it will come ahead. Now, if I start answering questions for topics which are going to come after a week, which is not relevant for you right now, because there is a stage of how we've built it. There's a reason why we've divided into sprints. If I want, I can start with rags. If you want, I can do rags today, right now, also. Shrishti can start teaching rags, but you will not understand rags because you've not gone through the basics. Similarly, why we did prompting on day one is because that is the most basic skill that you should have. So it is built in a systematic manner so that again, when we have one more session with Srishti in terms of Hugging Face and all of those topics coming next Tuesday, so over there also you'll understand and connect the dots better. So when we are answering this, that we are not doing it right now, don't ask me why we are not doing it. Don't worry, we will cover it. Whatever is important in the world of generative AI, we will make sure you know it. Okay, that is a promise that I have made. That is a promise that I will deliver. I hope that is clear.
Okay, nice. So we are good on that part. And anyway, I would say that, see, as a learner, if even I was in your place, I would also be concerned that, there is so much to cover, encoder, decoder, the theory and the mathematics. Why are we not covering it? I would also be concerned. But let me tell you the harsh truth. The harsh truth about the industry is that if you want to be a software engineer working in ML, so these days, I told you, I am working as the lead engineer. That's the title they've given to me. I'm going to call myself a machine learning engineer. Keeping my research aside, I'm not talking about research. Keeping my research aside, I do not use mathematics in my work. I don't need to know how transformers actually work to be able to succeed at my current full-time job. I don't need that. But yes, as part of my research, I'm going to be transparent that mathematics is relevant. How exactly, on a very minute level, your d by dx, your calculus that you used to study in school, even that is needed when I do my research. So that's the difference. Core engineer versus a research engineer, people working on research. Researchers would need the mathematics, engineers would not. And as my understanding says, this fellowship is the engineering accelerator. So less on mathematics, more on what you could do hands on. So we will now go hands on and we will understand a very important thing, which is why Hugging Face. First of all, do you people know what Hugging Face actually is? If I just Google it right now, Hugging Face. If I Google it, what comes up? It's an American company. It's a company. Hugging Face it's basically just a company. This company builds Python libraries to serve the open source machine learning ecosystem. That is what they do. It is a company. That is just like, a description of what Hugging Face actually is. The point is that if OpenAI is in the market, if Anthropic is in the market, and they are offering their models behind what? Behind a paywall. You need to go to OpenAI, you need to go to Anthropic, purchase their API keys, and then only you will be able to leverage their models. But still, the fact stands that OpenAI and Anthropic, they exist in the market. They come with the best models out there. Obviously, Opus GPT, they're all pretty great models, great at reasoning, great at mathematics, coding, whatever tasks you people want to accomplish with them. Why do we then need Hugging Face? Why do we then need Hugging Face, right? Because what is Hugging Face? Like if you go to Hugging Face, what's the first thing you spot over here? Models. Models, right? Hugging Face also has machine learning models. We were discussing what? Text generation. There's text generation over here. We were discussing other things, visual question answering, document question answering, those things are there. Models are available for every class of tasks, for every modality, be it computer vision, be it language, as in text data, audio, speech data, tabular, reinforcement learning, whatever. Machine learning is your platform for models, for open source models. The question is, why do you need them if you already have Anthropic, if you already have OpenAI? Why do you need them? One answer could be, well, if Anthropic is there, then OpenAI is also there. So why can't Hugging Face be there? That is one answer. But the thing is, my question is, when would you use Hugging Face and not OpenAI? And let me answer this myself. Let's say for people like you and for people like me who are willing to build dummy machine learning projects, or maybe like, portfolio machine learning projects, just to learn how we can leverage the power of machine learning for our products, how we can build scalable products with machine learning models as the source of intelligence behind them. How can we do that? Right? If we are wondering that, so the answer is, go to the market in the sense, not to the physical market. Go out there on the internet. You have OpenAI, you have Anthropic, purchase their API keys, pay money to them, and use their models. That is the answer. But my counter question to that is, I don't want to spend money. What if I do not want to spend money? I don't want to pay to OpenAI. I don't want to pay to Anthropic, and I still want to upskill myself in machine learning. What can I do? What can I do? I will go to Hugging Face. Because here I can do things for free. That is why we're learning Hugging Face. All right, here I can do things for free. I've given you a very simple reason that's more around money, but there are more reasons as to why Hugging Face exists. It's open source, like it's the sort of one core company behind open source ML. And I don't need to give you reasons for why open source is important, right? Because you people already know that, or you could go ahead and study that yourself. But open source ML is thriving on the shoulders of Hugging Face. That's what I would say, right? That is one thing. Now, one more thing. One more thing is that I am going to search some things over here. I'm going to search some models over here. Excuse me. I'm going to say Microsoft. Some Microsoft models come up. This model, 15B means 15 billion model. That's how big this model is, called 5.4. This model was built by Microsoft, right? This model was built by Microsoft. Then there are more organizations like Alibaba. Alibaba has their Qwen models. Qwen models are also a great series of models. This is their UI, but they must have their, yeah, this is their GitHub repo. They have their own Qwen models, a couple of models, lot of models, 3, 3.5, 2, 2.5, reasoning, math, instruct, vision models, language only models, this and that, a lot of models, even code models, right? Qwen 3 coder, Qwen code, lot of models. Qwen has their own models. We talked about Microsoft, we talked about Qwen. We can talk about more companies like Mistral is there. Mistral AI. Mistral AI has their own models, like Mixtral is there. So I can actually Google that for you. Mixtral is there, right? Their mixture of experts model. Mixtral is there. Then there are other like Mistral small, this and that, a lot of models. There is Mistral, there is Qwen, there is Microsoft, then there is Meta. I can open another tab. I can open another tab for Prime Intellect, another tab for Nose Research, this and that. Lot of companies, lot of models. All of them are great companies. They are doing a lot of building in open source. What is the problem? The problem is that if you want to use some Microsoft model, you will have to adapt to their SDK, their API, their library, whatever they're offering. For Meta, you will have to adapt to another SDK. You will have to, adapt to their ecosystem. For Qwen, you will have to adapt to their ecosystem. Same for Nose, same for Prime Intellect, same for Mistral. So many models being published by so many companies, labs, academic labs, people out there. How much are you gonna adapt? How much are you gonna adapt? What do we need? What's missing? What's missing is a common platform, a common API via which you can access these open source models, and Hugging Face solves for that. Hugging Face solves for that. One more reason why Hugging Face exists and why it's important. All right, I think enough motivation. Should we directly go into the code now, or are there still any doubts? A lot of doubts, I mean messages. Let me read them. Models, open source. Looks like these are all answers. Okay, a very important question asked by Gaurav, but how are they able to provide models for free? Training and hosting models is expensive, isn't it? This is a very good question. I'm going to answer it later on. Because first, I think let's cover some code. Let's cover some code. Let us understand how to actually use Hugging Face models for our work. Okay, let's understand that. Now, I'm going to tell you one thing. There are two ways to do that. Two major endpoints I can call, not even endpoints actually. Let's just call them two ways. There are two major ways to use Hugging Face models. One is simpler, very abstracted. You don't have to worry about anything. You don't have to worry about how models cannot work with text data. They need numbers. You don't have to worry about that with the first way. That first way is what I'm going to cover today. The second way makes you have more visibility into how exactly models are working with numbers and not text. That is what we're going to cover in the second session that we have coming up next week. All right. So I told you there are two ways. Maybe I can actually write it over here as well. There are two ways. The first way is the more abstract one, and it's called the pipeline function. That's the first way. The second way is a little less abstract. So the less abstract way, it's called the auto classes way. The auto classes way I'm calling it. Auto classes and auto models, or maybe I can call it auto tokenizer and auto models. Okay, tokenizer and auto models. This is what we're gonna do in the other session. Cool. There are two ways. Pipeline function, auto tokenizer, and auto model. One is what we're going to do today, second in the second session. I hope this is clear because the same outputs we're going to see in the second session. Some people might question, why are we covering the same thing? Yes, it's the same thing. Yes, it's the same functionality, but it is giving you more visibility, more insight into what's happening. And that is important whenever you try to experiment with these models, whenever you're trying to debug stuff, that becomes important over there. All right. Okay, let's go. Let's talk about Hugging Face, how to use Hugging Face. So the very first thing is, for some models, not for all models, for some models that are out there on Hugging Face, sometimes we need a token. Like you have API keys, we have a Hugging Face token as well. Sometimes we need a token, a Hugging Face token, to be able to access those models. And many a times we are just fine without it. We don't need that. So there is some boilerplate code, I would call it, over here. This code allows you to, just fetch your Hugging Face token from the environment so that you are well authenticated. This code allows you to do that, and that's just it. And all the token information is written over here. Let me actually show this to you so that it's all not left out. Okay, I'm going to show how to generate a token for yourself via Hugging Face. There is a link that's present in this Hugging Face notebook. You just have to go to this link. You go to this link and you'll need to enter, like you'll need to log in over here. It's asking for my password, which I entered, and I am logged in, right? From here, what you will find is that this is your user access token page. If you already have generated some tokens, they're all going to be here. But for your use case, you will need to generate a new token. Just press on, okay, let me go back. Press on this button, create new token. Give some name to your token, like could be anything. I'm not creating a new one for me right now because I already have a lot of them. So just give some name to your token and then click the permissions from here, whatever permissions you want to give to that, associated with that particular token. Just click the permissions and then press on this button, create token. A screen is going to appear. Let me actually generate one. March 24 it is, right? I just generated a token and yeah, I mean, these permissions are all fine because I'm anyway. Okay, I've just given all the permissions and then I'm going to click on create token. This is my Hugging Face token. Just copy it from here. Otherwise, like after this, you won't be able to copy it. So make sure you copy it, store it in some place where you can have access to it later on as well. And then that token you are ready to use in this collab notebook. All right. Cool. So once you have that token set in this notebook, instructions are all written over here. You just have to run this code and you will be authenticated. I am not doing that as of now because for this code, we don't need that. So I'm not doing that. But yeah, this is how you set your Hugging Face token because there are some models on Hugging Face that have gated access. You need to agree to their terms and conditions, generate a token, authenticate yourself, and then only you will be able to work with them. All right. So I'm not doing that as of now. And this one I'm going to delete because it's not needed. And yeah, we're good. Okay. Let's move on to this part of the code. Now, what are we going to study? We're going to see how simple it is to, to load just about any model from Hugging Face and use it for any particular task that you are interested in. So I'm going to cover a couple of tasks. The very first task that I'm going to cover is image classification. So what do? I told you Transformers is the core library offered by Hugging Face. We're just going to import the pipeline function from that library. And then these are two additional imports that I'm doing over here. From the pillow library, I'm importing the image class and then the request library for web-based downloads. All right. So what are we going to do? This pipeline function is as simple as providing just the name of the task that you want to accomplish, and then you're done. So what did I do? Inside the pipeline function, I sent an image classification. I'm not even sending the name of a custom model. By default, it is going to choose a model and use it by itself. I don't even have to do that. But if I want to do that, I can do that as well. I will write model and then I will send in a model name over here. And this classifier would be my object that's ready to do image classification for me. All right. So what do? I have an image URL. I just open it and then I send this image to this classifier. I get the predictions and then I'm gonna print those predictions over here. All right, this is what I'm doing. So if we just open this URL, this is a cat, and what's printed over here? Tiger cat. So the model classified it correctly that this is a tiger cat. What are these numbers? These are the confidence scores. With a confidence of 0.78, with a probability, let's say, of 0.78, the model thinks that a tiger cat is present in this link. What was behind this? An image classification model. What model was used? Defaulted to this model by Google, VIT Vision Transformer, a part of the Transformers library that is able to do image classification for you. That's what it defaulted back to. But if required, you could use your custom, like you could use a model of your choice over here as well. Now, how do you know what model to use? This is a common question that a lot of people have many times. How do we understand what image classification models are actually present on Hugging Face? How do we get to know that? The answer is you go to this models tab, and then from this side panel, you are just going to select the relevant task for yourself. What was my task? Image classification. I'm going to click on this. As soon as I click on this, a filtered list comes up for me. These are all image classification model. You could select any one of them. Let me select this one. I think already got used, right? Yeah. Let me select a different one. Maybe this one. I just selected this model. Now, how do I use this model? Let me actually teach you people. How do you use this model? How do you reach at some code that looks like this? How do you do that? So you've opened this model page and you're like, okay, this is the model that I want to use. One thing is that you just copy this model name, click on this button, model name would be copied, and you and you just paste that model name over here. That's how you can use this model. What you can also do is that you could go on this button. On the same page, we have this button, use this model. Click on this button. A lot of ways are going to appear. Because I am using the Transformers library, I'm going to click on Transformers. some code is gonna appear in front of me, which is exactly the code that I have over here. Same pipeline, image classification, model name. To this pipe, what are you giving? You're just giving a path to some image. What did I give to this classifier that I created over here? This image that I already opened over here. This is exactly the same code. Okay, I can maybe remove this for now because we don't need this. But yeah, this is how you just go to model pages, take the code from there, copy paste, and it's all done because it's all API docs. It's just a library, right? How do you learn to use a library? You go through the API docs. All right. That was for image classification. What we can also do is audio classification, and it's exactly the same technique. The key lies in selecting the best model for audio classification for your use case. What am I willing to do? Audio classification. I wrote the task name over here, audio classification. And then what model do I choose? Again, I'm new to audio. I don't even know a single model that is able to do audio classification for me. I am again going to go back to Hugging Face, to the models page. Because I'm interested in audio modality, I'm going to scroll down to the audio section. And what do I want to do? Audio classification. I filter, a list comes up. A list comes up. Any model you can select from here, paste that name over here. And then similarly, what do? You take a dummy audio file to your classifier, you just send that audio file, and predictions are going to be printed via this print statement that I have over here. All right. This is like as simple as it can get. Very simply, you can work with these Hugging Face models. Now the question is that this is fine. Like this is something that's pretty simple. You people can figure this out by yourself as well. If I now tell you to do sentiment analysis, it's not hard. You would just write something over here in place of audio classification. You would write what? Sentiment analysis, and then you would put in a sentiment analysis model. How? I've already told you, you already know by now. And then you could do sentiment analysis. My question is, if I press Command Z over here, maybe once more, here I had audio dash classification, but then when I wrote sentiment analysis, I used an underscore. How would you determine what exact name has to come over here? Sentiment analysis or emotion analysis? How would you determine where is that info available for you to look at? How do you know it's audio dash classification and not underscore? How do you know that? Can I please get some answers? API docs. Yeah, tab is also the right answer if you're using cursor. But yeah, API docs is the right answer. So the thing that I was trying to tell you is that this is not code that you have to learn. No, you don't have to learn it. This is all present in your API docs. You go to the API docs and you would understand how do you actually play around with this pipeline function. So let's say I use this model for audio classification and I'm like, I'm not getting good results. How do I go about it? How do I go about it? How would you go about it? You would go to first this page, filter by audio classification. You're going to get a list of models. But again, these are 4,000 plus models. It's not like you could try each one of them because first of all, you don't have the time. Secondly, who's going to do this copy pasting manually? Who's going to run through so many numbers? You can't try out all 4,000 of them. Then how do you select the best model for yourself? How would you go about it? This is the thing that I think I should be telling you. One thing is that all of these models, whatever models you are considering, when you go to their pages, most of them, or let's say some of them, would have some benchmark numbers. What's benchmark numbers? They would have some data on how their models are actually performing on real world audio classification data sets that are present out there. They would have some numbers on that. Check out those numbers and try to get a sense of the model quality from those numbers. Here I can't find any benchmark numbers. Maybe here I will. Not guaranteed. They've just given some plots. These plots are from I think, from the training of this model or whatever, maybe evaluation plots or whatever they've given. So benchmark numbers are not a guarantee. Sometimes you find them, sometimes you don't find them. If you find them, well and good. What if you don't find them? Then how would you determine that, what's the best model for my use case, for let's say my particular project? Let's say it's just a project that you want to dummy to people out there, like dummy showcase to people out there. How would you select the best model? If benchmark numbers are available, well and good, but what if they are not? Couple of things you could do. One thing is you go to forums like Reddit is there, Twitter is there, and figure out how people are talking about different models. One thing is most of the models would have research papers associated with them. So this is, forget this one, maybe we'll select a different one. Maybe this one. If I just copy the name, I go over here and then I type in archive, maybe I would find a paper. Some paper came up. I'm not sure if this paper is directly the paper that introduced this model or not, but yeah, some paper came up. What I'm trying to tell you is that corresponding to most of the models, you will find actual papers and benchmark numbers might be present in those papers. That is one thing. What if they're not? Then your only resort is to first select a suitable evaluation data set that represents your task. How would you find an evaluation data set? You again go to Hugging Face. You have this data set section. Go to the data set section, find a data set for your particular use case. What is my use case? Audio classification. I'm gonna click on audio over here. I clicked on audio. Audio datasets. This is the list of audio datasets over here. Now I will need to go into them and understand what datasets are actually audio classification datasets. I would take that dataset. I would evaluate a couple of models on that dataset and understand what's the best model for me to use, and then I would use that model. This is like a mini strategy as to how you could go about trying out, different models and selecting the one that fits your use case, right? Sometimes Hugging Face has pretty amazing data sets for a use case, sometimes not, in which case your only option is to create data sets of your own. Cool, let's come back to the code. I can see one hand raise. Shreya, please write your doubt in the chat. I'm going to check the chat in maybe like 10-15 seconds. Write your doubt in the chat. We are done with audio classification. Now I'm going to walk you through a little bit around the data sets library of Hugging Face that I just mentioned. Okay, have you written the... No, you haven't written your doubt yet. Why not automate this process? Automate what process? Of selecting the models? You could do that. You could always do that, but human intervention is needed because in theory things might look very, very simple to you, but when you're working on, building actual products, it's not that simple, right? It is not that simple. There are a lot of nuances. They're all in the data. And then you will have to, experiment yourself. Full automation is a bit hard. Anyway, yeah, what are our job with the collab URLs? Are we going to follow you with the code? With the collab URLs, you can run that code on your end. Make a copy, try running that code on your end, and you will understand if the code is working or not and whatever is actually happening in the code. Okay. Now let's discuss a little bit around the datasets library of Hugging Face. I just talked about it. It's a very simple library. The way you work with, models, pretty similar to that is how you work with datasets as well. What do I mean by that? I click on some dataset. This is a dataset that let's say I'm willing to use. So what I would do is, can I find the usage somewhere over here? One second, I think the usage is not over here. It should be. They've given SQL queries. Yeah. This is where they have given the, the Python code using which, like the datasets library code using which you could actually work with this dataset. They've given some code, but I'm just gonna make you familiar a little bit with this most common function, that is load dataset. A function inside this library datasets. What you do is that you just provide the name of dataset to this load dataset function, and you're just gonna get your dataset downloaded from Hugging Face. All right. Once you have your dataset, you can just print it, see what the structure is like. Sometimes you have train validation and another split called test split. Sometimes you just have the train split. Sometimes you just have the test split. All of that info would be printed over here. What are the different columns? what are the number of rows in that data set? And one example looks something like this. I just printed one example. I took the train split and then print the very first example of that over here. This is what it looks like. So this is how you get a feel for what your data set actually looks like. Sometimes what happens is that the training split of the data is actually absent. You only have the evaluation split, in which case you have to be a bit careful around actually, training your model on that eval split, because that's not a good practice. So these kind of things can happen. This is how you could just go about this. All right. Okay. Now, let me see if there are any doubts or not. All the hand raises, please put your doubts in the chat. I'm going to go through the chat for the next 10-20 seconds. Please give the collab URL. Karthik can provide that to you. Is there any workflow you are using to
Collab
make
has been
this?
shared.
Okay. Any workflow you are using to make this process more convenient? Which process? Arthur, I think, is asking this question. If you can specify the exact process, I'll be able to answer you. Please, can you explain the dataset training part again? Yeah, so what happens is that, as we saw over here, in this dataset, there are two separate splits. One is the training split, one is the validation split. Let's say tomorrow you are trying to, okay, let me actually write something for you, because actually that's a good question. I'm writing over here. Please follow along with me. What I'm saying is that, let's say you chose a data set to evaluate a particular model on. Why would you do that? You chose a data set, you're like, this is a data set, an audio classification data set. I have this model. I want to understand how good this model actually is. So I'm just going to evaluate this model on this data set. If the accuracy is like 95%, that means the model is great. This is the scenario. Okay. Actually, you people are going to answer me. This is the scenario. And this is point number one. Let's say you chose a particular data set to evaluate a model on. Second is you use HF, the code above, I mean. Use the code above to look into that data set and found only train split. That's what you found. This is one more condition added to the scenario. Third thing is you evaluate your model on this train split, because that's the only split that's available. You evaluate this model on the train split and get 99% audio classification accuracy. And then what do you do? In pointer number 4, you go to your CEO. You like, or maybe your CTO, and you're like, you know what? We're trying to do audio classification, by the way, a very popular use case for companies out there, even today. A very popular use case. You go to your CTO, you're like, this is a model, gives 99% accuracy on this data set. That's an audio classification data set. We should definitely work with this model. Either we try to see if OpenAI is making this model available, vague, very weird sort of thing to say, but I'm still saying it, or we, look at some vendor like Together AI that can actually deploy this model for us on their hardware. We could just pay something to them, and in production, let's use this model. In production, let us use this model that is giving 99% accuracy on this audio classification dataset. This is the scenario. I hope the scenario is clear. What happens? You go to Together AI, you deploy your model, you are now giving that model inside of your product to your users. Your users are using your product. In the backend, the model is being used. But what you figure out is that when that model is being used by your users, the audio classification model is actually performing very badly. 50% accuracy. That was close to 100% when you tested it. Now it's 50%. What happened? What happened? Did Together AI mess with your model? They would not do that. They have better things to do. Did your model magically change over time? Doesn't happen. What happened? You tell me what might have happened. And I'm going to tell you one thing. The answer is written, clearly written in these 3 points. You tell me what happened. No validation, incorrect data set, only training. Yeah, mostly the answers are correct. What happened is that when you looked into that particular data set that you got from Hugging Face, you saw that only the train split is present, but you did not check whether this data set was used to build this model or not. You did not check that. If that data set was actually used to build that model, because only the train split is available, the train split is telling you, I am the train split. I am used for training models. If this data set was used to train that model, the model is obviously going to perform well on that data set because that data set is seen by the model. That's what was used to build the model. That is why this 99% accuracy might be a bloated number. That's what might have happened, all right? This is why the train and the eval splits are important to consider when you are working with these data sets, when you're trying to understand what to actually do with this data set. In some cases, maybe a validation split, eval split is missing. Then you have to first check whether the train split was used or not used to train the model. If it was, then there's sort of no point in evaluating your model on that data set. That's why this is important. Okay, so there are like couple of more use cases that are written over here. These are for, so this is for automatic speech recognition. Same thing that we did with audio classification. You could go over this on your own. One more is there, which is summarization. Here I want to cover these 3 things. Okay, this is what I want to cover. Before that, are there any doubts? These are answers. Are there any doubts? Nice. Overfitting, what other splits are there? So, okay, what other splits are there? There are 3 major splits. Train, then you have eval, some people also call it validation, and then you have test, answered in the chat as well. Does Hugging Face also host? Host is not the correct term, but yes, there are small language models available on Hugging Face. Do prod datasets not redefine the model? No. No, that's not how it works. How can I train with my dataset? Okay, training is not what I'm going to cover, so can't answer that. But in order to train your model on your dataset, you would need to first build the infra, get the appropriate hardware, and then you will be able to do that. How to evaluate your model on the available dataset split? Yeah, you would just, you have the data set, you were just going to get the predictions. So the way you're using the pipeline function, you would use that pipeline function on not just one single data point, but the full data set, a for loop, a parallel for loop. That's it. So how to again choose which model if even 99% doesn't fit our use case? You will have to try and test. How do I know the model would work? I am using an Intel computer, does not have NVIDIA GPU. How do I know if the model will work on so and so device? Yeah, it's like not exactly independent of the hardware, but you should always try. Most hardware is supported. You should try. Do we need to deploy Hugging Face models ourselves? This question will be answered probably later on. How safe is the selected model? Safe in the sense your data is safe because it's all the computation is happening on your local laptop in the examples that I'm showing you. So your data is safe. Can we download the model and deploy it in AWS EC2? Yes, you can do that. Is there any security concerns while using models from Hugging Face? Data security concerns are not there. They are not there because everything is running on Hugging Face. Yeah, when you use vendors like Together AI to deploy your models, maybe yes, you will have to check with them. Okay. Isn't test split eval split? No, they are different. Eval and test are different. Eval and test are not the same. No, they're not the same. Data sets are available. What are your tips and tricks to move over those model choice and data set evaluation? Tips and tricks, that's a good question. Uh, hmm. So there are these, guiding principles. One is that what are the most standard benchmarks for that particular task that you are working on? How is your model performing on those benchmarks? First, you test that. If it's not performing good, obviously you discard it. If it is performing good, then you maybe check with, some ground truth or maybe some proprietary data that you have with yourself. Check with that data. If it's performing well, maybe you try rolling it out to your users. And if it's not, then maybe you try to understand why the model is actually performing good on benchmarks, but not on my proprietary data. Maybe your data is too difficult. Almost always happens. When you are working with actual ML products, that almost always happens. So what you can do over there is maybe fine tune the model, maybe build some RAG type of system, something you're going to study, some agentic, those kind of things, get better context, and then it all depends on your task. But these are a couple of things. Benchmarks are always standard, and then from there, it's on you to try the model as extensively as you can. Maybe build synthetic evaluation data sets and understand what are the failure modes for your model. So it's all a story around what? Data sets and numbers, data and numbers. So data, which is the boring part, is actually the most important part. Okay, we're good. Yeah, I was saying that I want to cover these three things whenever, like here I'm just trying to summarize some text. So I want to cover these three things. What are they? The first is min length of the summary, max length of the summary. This is pretty clear. But what is this 25 and 50? What 25 and 50? 25 and 50 words? 25 and 50 characters? What 25 and 50? Can people give me some answers? Because you've already studied this, so you might know. Tokens. Yeah, tokens, exactly. This is what? This is the this is how we're defining the number of tokens. And tokens is something you people already know. So tokens is the correct answer. Now, what about this do sample? I am expecting that people might actually not know this do sample thing. So let's start with understanding what is this do sample? Like, what does this actually mean? So one thing is that because you people have already studied tokenization, can you tell me when models generate answers? And when I say models, I am specifically talking about, let's pick one model like GPT 5.4, specifically talking about those class of models, text generators. When they generate answers to your queries, how does it happen? Is it one sentence at a time? Is it one word at a time? Is it one character at a time? Is it two words, three words? What determines that and how does it work? Can I get some answers on that? Word by word, one token at a time, next token at a time, next token, all tokens processed parallelly. Okay. Okay, someone has written token, which is roughly 0.7 of 7.5 of a word. Okay. Okay, cool. So a lot of right answers over there. Answers or like whatever, the text that's generated via these decoder only models, these models that we work with, Opus is there, GPT is there, they are generated one token at a time. How are they generated? One token at a time. And obviously, this is the reason why whenever you go to OpenAI and Anthropic, pricing is always in terms of token. Because tokens are like that is the smallest unit in which generation is happening. Now, let me tell you one thing. We discussed in the beginning of the session Models are just mathematical functions of data. We discussed that. Then I showed you this thing, this huge figure. Can I zoom out? Yes, can zoom out. This is a model. This is a model. The data is coming in from here, and then a lot of processing takes place. So if I take you through it from here till here, it's a lot of processing. I would like to zoom in specific parts of this architecture, but for some reason I can't. Maybe this is fine. Yeah, a lot of processing is taking place. A lot of processing. All of this processing. If you go to, Hugging Face, you would see that there is, numbers. So this one has what? 35 billion parameters. That tells you about the size of the model. This is such a big model. 35 billion parameters are present inside of this. All of these calculations are happening to do what? Just generate one token at a time. So even if you have to generate a full stop, which is a token, all of this calculation has to take place. This is why it's an expensive thing, right? It's very compute intensive, it's expensive. Models are running on your GPUs are expensive. That is why the pricing always comes in the form of tokens. Per tokens, this is the price. Why is tokens the sort of the currency of LLM? I think you people now understand that. But yeah, what was I trying to explain with this do sample thing is that now let's go back, and we are going to take a break after this, so don't worry. I know you must be tired. In the beginning of the session, I told you models are functions of data. And then I told you that they are mathematical functions. Mathematics doesn't know a thing about A, B, C, D, and the way you talk to models, code data, like your text data. Maths doesn't know a thing about that. Maths knows numbers. Even your computer doesn't understand anything above 0 and 1. Maths works with numbers. Your models work with what? Numbers. The thing is that whenever your model gives some output, that output is not a token, first of all. It's not a textual token that your model generates. Your model, now, okay, I'm wondering whether I should say this thing or not because I just don't want to confuse you people. So maybe I'll just create a slide for it and I'll write it because writing is always better for clarifying things. See, pointer number one is what? Models do not directly, the word directly is important, generate tokens. Now, you people only told me in the chat that we do one token at a time. So, one token at a time is fine. What do models actually generate? They generate, I am telling you, first time I am telling you, this is a new concept, so don't worry. They generate probabilities. Actually, they generate logits. Right, so to be technically correct, logits is what they generate, but logits you people don't understand. Probability everybody understands because standard 8 thing everybody understands probabilities. Models generate probabilities. I was telling you models, they're mathematics, mathematical functions, they generate numbers. What are the numbers? I just took you one step lower than that. One step lower into the whole, like whatever pipeline, whatever you want to call it. Models generate probabilities. Now what probabilities? Now consider this scenario. An input comes in. Hi, how are you? You give this to ChatGPT. ChatGPT generates some answer. How does it generate it? One token at a time. You already told me, right? One token at a time. It's now ChatGPT's job. Okay, I can write it over here. It's now ChatGPT's or whatever. GPT's job to determine what the next token is. It's GPT's job to determine what the next token is. What GPT actually gives you is probabilities, a lot of probabilities, like this 0.66, 0.6, not can't be 6 anymore because its probabilities has to sum to 1, 0.01, something like 0.0, like whatever, you people get the deal. GPT or any machine learning model that's doing text generation, it gives you a lot of probabilities. Now what? I mean, I've told you a couple of things. Models generate probabilities. I told you this is how those probabilities look like. The model's job is to generate the next token. There is one bridge in between of them. The bridge is that GPT doesn't directly tell you the number of that token. Okay, token number 100 is what you have to generate. That's not what GPT is going to tell you. It is going to generate one probability for each token in the vocabulary. You already have studied tokenizer, so you must know what a tokenizer vocabulary is. All the tokens recognized by that particular tokenizer. GPT is going to generate one probability corresponding to each token in the tokenizer. So it's telling you, okay, well, your tokenizer has 50,000 tokens. So it's going to generate how many probabilities? 50,000 probabilities. Let me write over here. 50,000. This is 50,000, yeah, 50K. If the vocab size is 50K, it's going to generate 50,000 probabilities for you. It's going to tell you token number 1 has a probability of 0.66 for being the next token. When GPT generates probabilities, we are the model creators, researchers, they do things on top of those probabilities to determine what token is going to be the next token. What token is going to be the next token? Okay, that was a lot actually. I hope you people are not confused. But okay, whatever. Yeah. So I told you that GPT generates probabilities corresponding to each token in the vocabulary. Now it's your job to say that, okay, this token has the highest probability. This is going to be my next token. This is one way that you can go about it. But you can also say, these are the top 5 tokens with the top five highest probabilities. I'm just going to select one out of them. Now it's up to you. So this strategy, how do you select your next token from using that probabilities vectors given by GPT? This is known as your decoding strategies, and that's what is meant by this do sample thing. That's what is meant by this do sample thing. See, if do sample is false, we just select the token with the highest probability. This is why I went through all of that, models are math, and then no tokens are generated, numbers are generated, probabilities are generated. That's why that info was important. Now you people must understand what this actually means. You people must understand what this actually means. Okay, I think enough of that math and all, because I know you people don't want to cover math. Why does it keep going back? Whatever. But yeah, now this is fine. Do sample is fine. Now, what is the practical use of this? Why should we care about do sample? Why should we care about it? So the thing is that I'm going to write it in pointers. If you want more creativity in your model generated answers, then you set do sample to true. You set do sample to true. And what does that mean? That means that you don't just select the token with the highest probability every time. Because let's say you are a poet, you are using your machine learning model to write a poem for yourself. And then you say, okay, complete my poem, the sky is. And every time your model generates blue, 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 and blue, because that's the token with the highest probability, you are getting zero creativity in your poem. You want more creativity. You want more creativity in your story, or sometimes in your code as well. That is when you set this do sample to false and you use some different strategy to select the next token. What are those strategies? How do you select that? We're going to do it in the next session. Because for today, I think this is already too much. Some people are already writing it scattered. We're not able to comprehend. That's how ML is. I can't really help you there, but I'm going to answer all your doubts. All right. So I hope this was clear. This is now time for a break. After that, we're just going to cover Gradio, temperature and all of these settings. So someone has written, is this the same as temperature? Well, temperature is somehow related to this concept, not exactly the same as that, somehow related to that. We're going to discuss that next time. Today, I just gave you an intro to this thing so that for next time you are prepared. Because today we already covered models are math functions, so it made sense for me to also mention this point today. Okay, cool. Then let's take a break and we'll come back and discuss Gradio.
Srishti, okay, you're putting a 5-minute timer. While you do that, please check WhatsApp also.
All right.
Folks, we are on break. So for people who are on break, please continue. So, there were two, three people who were facing issues with LMS. So I thought I'll just use the break to send them the link of where they can get the recordings or where they can get the WhatsApp community. That's fine. This is your LMS. As soon as you log in with Google, this is what you will see. The first thing you will see is this. Scroll down. You see this onboarding troubleshooting. There's something called as See More. Click on See More. Scroll down. Here is your WhatsApp community. Just join the WhatsApp community through here. As simple as that. Recordings and resources are over here. You can close these startup at prerequisites. Kickoff. Kickoff was the Friday session, by the way, folks. The Python part. Session recordings of day one of yesterday, along with post reads of yesterday, has been uploaded. So if you want, go here. You can also see the Excalibur links, GitHub, prompting guide, JSON prompt. All of the links that were shared by Sid are over here. I hope that helps.
Okay, the break is almost, actually, it's over, but
Folks, is everyone back from the break? If yes, please put it back in the chat.
yeah, cool. Okay, I will share my screen. Okay, I hope this is visible. Let's start. We have to just cover, one broad topic now, which is Gradio. We'll understand what Gradio is, why, like its significance as far as building models is concerned, and yeah, we'll take it from there. Let me close all the irrelevant links. This is fine. This is also not needed, not needed. Gradio is needed. And then, yeah, then we also have a little assignment for all the learners. We are going to go into breakout rooms and discuss, like, do that assignment together. Not really an assignment, it's more of an exercise. So it's pretty easy. So we're going to do that. Okay. One thing is that I'm going to shut my door. Give me a moment. And then the second thing is that Karthik told me that the way I've been saying this phrase, like, the way I've been referring to everyone as you people, which is more like a habit, is actually considered rude in some parts of the word. So I'm sorry for that. Like, I totally respect this. And very good that someone spoke up. I'm not sure who it was, but it's always great to, speak up, let others know when they are doing something that's not considered appropriate, so that the other person can also correct themselves. I'm also going to correct myself. And even if I say it by mistake, just understand that this is my habit, which I'm going to improve, and I'm not being rude. Okay. Anyways, thanks a lot. Let's carry on with our discussion. Okay. Now, the thing about Gradio. So, the thing is that there are, a couple of things that we've been discussing. What are models? What's model training? How is it different from model inference? We looked into just a little bit of the mathematics thing as well. I'm not exactly the mathy details of models, but yeah, just that probability thing is also what we looked into. The thing is that whenever you are working in industry, especially, but somehow this holds true for you are, in the sense, whenever anyone is, like whenever we are working in the industry, or if we are part of academic labs, like, university labs and just research labs like that, many a times it's very important for us to, give to the world a way to test the models that we've built. What do I mean by that? Let's say today I write a paper in which I claim that my machine learning model that I'm proposing as a novelty as part of this paper is the best on ASR, automatic speech recognition. It's the best, so good that it doesn't even mess with different accents, domain specific terms, terms that are very rare, too complex, even Gen Z slangs, doesn't mess with anything. It's literally the best out there. That's what I claim in my paper that I get published in some A-star conference. It's a dream for me, for many, for all of us, right? It's a dream. Let's say I do that. The thing is that I am claiming that, and that's okay. And then I make my model open source, and then I'm like, well, try out. I tell the world to try out my model. Maybe I made it available via some paid API as well. Although before doing that, there's a lot more work that needs to be done. But yeah, let's say I do that. The thing is that making the model available via Hugging Face is one thing. And then there is one thing wherein you have, a nice like front end, a nice like UI created for your model, wherein let me actually show you something. So we go to Hugging Face, and then we go to this button over here, the third button after models and datasets, spaces. We go to this button, and I was talking about audio, right? Let me select audio from here. Do we have audio? Audio. This is search bar. Audio transcription. Like this. This is gonna take a while to load, but yeah, like this. So what's happening over here? It's just saying drop your audio note over here, or maybe paste a URL, and then it's gonna give me the transcription, the exact text, the exact, the words that are spoken in that particular audio. This is like, this is a way to very easily, in a very user-friendly manner, try out machine learning models. So while I am not a front-end developer, I don't know front-end, to be honest. I know a little bit of backend, but also not a lot of that. What I do is I do machine learning. I am a machine learning research engineer. You ask me about transformers, you ask me about how to improve this model, how to improve this product that's using ML, how to do context engineering, how would you make sure that Claude becomes safer over time? Those kind of things are what I do. But I don't do front end. So I'm sort of bottlenecked, right? I want a nice UI, a nice interface for my users to try out my model. I want to showcase my model to the world. Releasing a paper is all good, but how do I, reach even that audience that is not interested in reading the paper? I want some UI. I want some front end. Can't hire a front end developer. What do? I just go to this library called Gradio, which was built by a Stanford PhD student to solve the exact same pain point that I've told to you people. Maybe you could search, maybe I can also search that for you over here. The name is Abu Bakr Abid, the person behind Gradio. He was a Stanford PhD student, like he was still pursuing his PhD while he built this library just to solve this exact pain point that I told you. That you know what? ML researchers, ML engineers are very good at building models. They understand the dynamics. They understand, okay, what initial data is important, this data, that data. They understand a lot, but they have no means to showcase their models, or maybe even like a system that they're creating, like a product that they're creating out of a machine learning model to the world. What do we do about it? Abu Bakr Abid built Gradio. He built Gradio to solve this exact pain point, and then Gradio got acquired by Hugging Face. That's why, actually, that's not why, but yeah, it's a part of Hugging Face. So we are discussing Hugging Face, we are discussing Gradio, which is a part of Hugging Face. So I hope the reason behind why Gradio exists and why we want to learn it today is clear to everybody. Okay. And the thing about Gradio is that whenever you are targeting a library towards machine learning engineers, machine learning researchers, or whatever, Python is the language that they are the most comfortable with, right? Python is, although, of course, C++ is cooler, faster, but Python is the language that we primarily code in, that we primarily work in. So the thing with Gradio is that, of course, has a Python API, but it's also super simple to use. Like I would say even a high school student would learn it in just like as 5 seconds. That's how simple it is to use and to understand, right? So let's go through some use cases of Gradio. Like I've just built some Gradio demos for everyone to understand and learn from them. We'll go through them, and then we will also encourage you to use Gradio as part of the exercise that we're going to do as part of the breakout rooms. Okay, so yeah, very first, obviously, you have to, Gradio has to be installed. Pip install Gradio, and then we just import Gradio as gr. What am I doing over here? I've just created a pretty simple function called greet, takes in a name and gives me a complete string, hello, comma, and that name. Just a very simple thing. Don't even need to explain. What I did over here is I built a UI for, this exact function. That, okay, this is a function, it's written in code, but if you want to showcase this function as a UI to people, what would you do? You just use the interface component of Gradio. Now let me write one thing over here. Gradio has two primary components. the classes that we can build with. First one is called interface, and the second one is called blocks. Interface is for more simpler kind of UIs where you don't need a lot of customization. Blocks is for more customization. Today we're going to deal with interface, the simpler one. Okay, so just simply the Gradio component gr.interface. Here I've written fn is greet, as in function greet has to be used in order to process whatever input comes in. The input is of textual type, output is also of textual type. You just do demo.launch, and while it's not running right now, I should actually run it for everyone. I can run it. Yeah, I'm gonna run it, and we will all see what it looks like. It's actually gonna take a while. Already running, but yeah, okay. I would encourage everyone to try and run this on their end to see what it actually looks like. Just want to demonstrate, like tell one little note over here. That's why I am taking the time to run it. But after this, we're fine, not running whatever other cells. While this run, let's move on to the other cell. Here, I'm just defining another function as simple as the previous one, just that there are two parameters, name and age, and you are saying, hello, this name, you are these many years old. Again, that interface, function name, but here something changes. What changes? Your input is now, the input that we are providing now is like twofold, two inputs we are giving. First is textual, the second is numerical, and the output is of textual form because we're returning a string from here. Is this running? Yes, this is running. So this is fine. Here, if I give my name or like any name, let's say Zane for that matter, and if I submit it, it's gonna say hello Zane. The point is that I just wrote this simple line gr.interface. I supplied my input type, output type, function name, and this got built out, which is okay. What if I wanted it to be shown in a different manner? The name box over here, the output box over here. Right now it's all in one line in a horizontal row sort of. What if I want both of these boxes to be a part of, like a column, first box, second box? What if I want that? That sort of customization is possible via Gradio blocks. This is what I wanted to like say over here, that while we are building things out using interface that is much simpler, blocks allows more customization. Blocks even allows you to do stuff like, first row, and then three boxes in the first row, second row only one box, third row three boxes, stuff like that. Custom themes and all of that. But today we're only going to cover interface, but yeah. So this, I don't think I have to run this. This must be clear by now. Now let's go to something that is a little bit like doing a little bit more calculation. So this is a very simple function again, analyze text. Whatever text we just get the word count, the character count, and then we display that. So we are returning two things as part of this function. That is why in the outputs parameter over here, I'm supplying a list, text and text. Both of these are textual. The input is also of textual form, again an interface, and then I launch it and it's gonna run. Gonna show me something very similar to what we saw earlier. Okay, output 0, output 1, two output boxes because obviously we had two, like two parameters, like two placeholder fields, whatever you want to call it, supplied over here. That's why we have it. So I can write hello again, and then I submit it. It's gonna print the word count and the character count. Now, one thing is that this is like a one-to-one mapping. Because I'm returning word count as the first thing, word count is being displayed in this box. If you want to interchange, you would just do something like this. Do something like this and it will change. Can run it again and we can see it will change. Changed. Yeah, as simple as that, right? Okay. these examples were super simple. From here on, what I'm going to do is I'm going to first run, we will see the output together, and then we will see what code component caused the output. I think it's more interesting that way. Okay. So yeah, what is happening over here? As soon as I run this, as part of this UI, I can see that some bold text is also printed over here, which was not present in the earlier UIs, right? This is what I see over here. Why is this happening? Because of this title component that I passed to interface. Okay. Earlier we saw that there were two output boxes, but both of them were not labeled by something meaningful. It was just output 0, output 1. What if I want to give custom names? That is also possible. How? Via this component. Echo text. It's written over here. Echo text got printed over here. Right? So what am I actually saying over here? That the output actually is going to be displayed in a text box, gr.text box. And what is going to be the label of that text box? Echo text. Same case for the input function, and this is pretty simple, same as earlier. Fine. Let's run this one and see what happens. This ran. I just have to supply one number over here. 4 is fine. I didn't type 4, though is someone else also using the same notebook. I'm not sure, but yeah. I submit, it's fine, like double number into 2, this should return. Why is this -6? I think people are working with this notebook as I work through it. Maybe that's why this is happening, but yeah, it would give double of the number that I'm gonna enter over here. Yeah. So what was I saying? That earlier we were using gr.text, but now because we have numerical inputs and outputs, the component just changed to gr.number, but rest of the things remain the same. Okay, now what if I want something like, some UIs also have this slider component that you can slide just to maybe increment a number or maybe do something like that. For that, we have a gr.slider component wherein we could supply the minimum value, the maximum value, and then also give a label to that slider component. And this is how it displays like this. And then if I submit, it's just going to calculate the value based off of this function. I think it's doing +10 or what? Yeah, here it's 60, here it's 70. Just adding 10 to that. And that logic is not important. What's important is to understand the different components that we can build with Gradio interface. Slider is there, gr.number, gr.text. That's what we can do. Okay. Now, we have this thing, check boxes. Like if you click on those check boxes, they turn into a tick, something like that. Something like that can also be built via the gr.checkbox component. If I check this, submit this, it might say something like checkbox is checked, uncheck, and then submit is not checked, something like that. The point is that currently I am teaching all of these components to you in isolation: slider, number, text, checkbox. What generally we do when we are building Gradio apps is that we take all of these components together and then build it out. So currently we are going through this together in isolation, and then we're gonna take all of these together and build like a nice UI out of this. Okay. Drop down input and text input. Oh yeah. So this is for the drop down component. Drop downs are like, you click an arrow, a list comes up, you select something from that list, and then those sort of selections are also possible via Gradio. Just gr.dropdown component, give all the options that you want to be present in that list, give the label to that drop down box, and yeah, this is how it. So here's what we have: option A, option B, option C. What if I do like this, change the order is going to change over there as well. So this is like a 1-to-1 mapping again. Option B, AC. Okay. The drop-down component we've covered, checkbox, text box. What else we've covered? Slider. And then there is image. Obviously, if we have text number, then we also have images. Image component is like pretty similar to how it is. how the text box component is. And yeah, just upload some image. It's gonna do something, process that image. Here, I'm not doing any processing. I'm just gonna like give the same image as the output, but we can do processing like what? One second, like passing image through an image classification model. So image classification, which is a use case, that is how we could wrap this up and present a Gradio UI for that. I can see one hand raise. Kindly put your doubt in the chat. I will definitely answer it over there. Okay, cool. Now these are some like more customized components. Here, this is commented out. Let me uncomment this. I'm just gonna run this one and then we'll go to the next one. Let's see what's happening over here. I think this is, yeah, what's happening over here? Up until now, we were showing text boxes, but those text boxes were like empty. There was no placeholder text. Here, I wanted to, display some placeholder text. That also I can do via this placeholder argument. And then lines 2 is what? What is lines 2? This box is visibly bigger than this one, right? Lines 2 controls the size. How many line space would be default as in this box? That's what it determines. Okay, so yeah, most of the components I've already covered. Now, one thing is that the whole motivation that I started with is that, well, build machine learning UIs to be able to share them with the world. That is what I said. Here I built them, but how do you actually, get like a URL? How do we get a URL that we can actually share with other people so that people can, other folks, other researchers or engineers who are interested in our product can actually access that URL to be able to use our model. Just a simple thing. Whenever we are launching our Gradio demo via demo.launch, we just set share is equal to true. We get a shareable URL that we can share with other people, and that link actually is valid only for 1 week. That's the story about it. One very important point is still missing, which is that we understood Gradio components in isolation. We built them out. Well and good. We also understood how to get a shareable URL that we can share with our friends, our coworkers. That is all good. The important point is where exactly that compute is going to come from. Where exactly is this app or whatever logic is behind our Gradio app is going to run? As of now, if I share this URL with everybody here, I say copy link address, I go to the chat, put it over here, and everyone in like all the learners can now access this link. But the moment I shut down my laptop, it's gone. Because this is still local to my laptop, right? The hardware, the compute, everything that's being used is still like it's my laptop. Of course, this is Colab, so Colab resources are being used, but if it was VS Code, then it would be my laptop's resources, but still, doesn't matter. Even if it's Colab, I share this with you and then I shut down my laptop. Whoever I share this with won't be able to access and use that link from there. That's the problem, and a problem that we obviously have to solve. What do we do for that? Hugging Face Spaces solves for that problem. Spaces. Now, what is Hugging Face Spaces? Hugging Face Spaces, we could consider it like a service wherein we could sort of deploy our Gradio apps so that those apps will now run not on our laptop's local hardware, nothing to do with the local thing anymore. Those apps are now going to run on Hugging Faces hardware, whatever hardware Hugging Face is providing to us. Now, let's just, for 5-10 minutes, I'm going to go through this and then we move on to that assignment. How do we create a space? New space. I'm going to give some name to my space. Could be like demo. This is March 24th. Something like that. Short description is fine, demo. Because I'm using Gradio, I'm gonna like Gradio selection is fine over here. Now this is the thing. Space hardware. This is where we select the hardware that is going to be used to run our Gradio demo. CPU is free, but zero GPU, and then any custom hardware that we want to select from here, a list of NVIDIA GPUs is going to appear. We will need to pay for this. Okay, we will need to pay for this, and this is one way via which Hugging Face earns. Okay, so it's not like they're providing everything for free. They have their own ways to earn. This is just one of them. I am going to select CPU basic. I am going to keep my space as public, and I'm going to create a space. What happens when I create a space? What I simply have to do is I just have to take my Gradio code, put all that code over here, and I will be ready with, the space, the UI that I'm seeing over here will be ready for everyone to try, regardless of whether I shut down my laptop or not, because it's not local anymore. It's running on Hugging Faces hardware. That's just it. Do we want to build this? I think yes. I go to files. Simply what we do is I am going to upload, no, not upload. I'm going to create a new file over here, create a new file. The file wherein my actual Gradio code goes has to be called app.py. This is a requirement. It has to be called app.py. I am just gonna take my code. This is some very simple code and looks fine to me. This might not be needed. Feel like I'm good with this code. Okay, let me try to push this file and then I will see whether it's working or not. I covered this file. It is building. It's saying building the space. We will see in a few minutes and check back whether this is ready or not, but let's move on to our assignment because time is running. Okay, this is the assignment that I have prepared for everyone. Let me see in the chat if there are any questions. Does this mean compute in GCP or Hugging Face? This is Colab provided. This is a good question and this is Colab provided. So this is Google resource. Okay, this is fine. I am just gonna share this notebook with everyone. Gonna set the correct permissions. This is our breakout assignment. Anyone with the link can now share. Just copying the link, submitting it over here. This is our breakout assignment for today. All we have to do is a very simple thing, not too complicated. Earlier, this was something else, but I figured out that a different Transformers version would be needed for that. So I made it even simpler. What we need to do as part of this assignment is that we have to build a Gradio UI, just the way I was showing Gradio UIs right now. We have to build that. The user should be able to supply a textual input, and the output should be the sentiment present in that input. So a sentiment analysis task. We will need to load a sentiment analysis model from Hugging Face, give the output to that, give the input to that, get the output from there, and display that output in the Gradio UI. This is the assignment. We are going to go into breakout rooms, do this. I've already shared the link to this collab notebook in the chat. Everyone, please make a copy of it. Start writing your code in there. I am going to enter your breakout rooms one by one. I'm not sure how that happens. Karthik is going to help me through it.
Yeah.
And then we will do it together, okay?
Before we go into breakout rooms, one thing that I would like to show, Shruti, if you could allow me just sharing my screen.
Yeah, I'm going to stop sharing.
Yeah. Second, post that someone else also wants to say something. So I'll get him also. Oh, my camera is off. Sorry. Folks, I have seen this issue happening before. That's why I'm just showing how this is done. This is what you will see, but you cannot make edits to it. As you can see, changes will not be saved because this is Srishti's, not yours. So when you open it, go to File. You can do Save a Copy in Drive. When you do that, it will take a couple of seconds or minutes depending upon your system, and it will open a new one. This is where you will be able to edit. because now this is saved in your drive. And if you want to write code, if you just hover over here, you see plus code. Click on it, and you can start writing the code from here. Okay? Was this easy to understand? Do you know now what needs to be done? Guys, do you understand the assignment? Okay. So, folks, when you go in the breakout rooms, how things work is a little different. Because in breakout rooms, you can unmute yourself, you can switch on your videos, and you can also share screen. So how that works is I will give you access after you get into the breakout rooms. You can unmute yourselves, you can start discussing. Each breakout room will have like maybe 16, 17 people. All of you guys can discuss, can build together as well. One of you guys can share the screen. While one of you guys is sharing screen, you guys can discuss, talk, get to know each other, and build it as well. Clear with instructions? Yes, no, maybe. Okay. How much time do you think you will take for this? Shrishti, how much time do you think we should give them for this?
I would think that okay, this shouldn't take more than 15 minutes.
Okay.
That
For
should be
buffer, we'll give 20. Okay. But before we open breakout room, uh, there is someone whom you know who's here who wants to talk to you guys as well. What's up, Ishan? How you doing?
Good man, still in the office. Hi everyone, how was the session? I was in the session for the last 1.5 hour. Thank you so much, Rishti, for going into like so much depth. I'm sure people would have loved it. How was the session, folks? Lovely. Okay, I can see a lot of hearts. Lot of hearts coming up.
someone is also
Interesting.
writing boring in the chat. My attention is always to
So theoretical, it was, folks, it
by
was
class.
meant to be this way because most of the sessions that you will have in the accelerator are very inference or applied related, but at some point you will have to study some fundamentals to understand the things. The reason I came up is something very quick, which I wanted to show you all. While Gradio is a very good tool to create demos and so on, something which I would want you all to pick up is this as well. Let me just quickly share my screen. Any front-end developers over here? Just type in yes in the chat. Any front-end developers do we have? We have a couple of them. All right. So folks, once you get comfortable with Gradio, even during the accelerator, you will get a bunch of assignments and all to work upon. There is something which additionally I would want you all to do. So typically this is what, just a second. This is what your Gradio app, the quality of a Gradio app looks like. You have some text over here, you have some image boxes, some output boxes. My screen is visible, right, Srishti? Yeah,
Yes.
okay. Yeah, give some prompt, submit it. So this is basically a Gradio app in which you can upload your face, you can upload any pose, give some prompts to it, and it will generate this basically image with your face and basically anything you can use to do that. But this is only good enough for prototype or for your examples. But if you have to actually share it with someone else, you should try to do it in React. So I will show you the exact same app where you can upload photos, write a prompt, add some configurations, and get an output on React. This is the difference which I just wanted to show you. So in this, like there are multiple sections. Here I can add, let's say, let me add my image. We'll add another, let's say, I will put it here. I'm not running this now because this requires a GPU. I can select any of the styles over here, write a prompt, image in the desktop. Next, change some parameters over here. All of this is interactive. Alter the negative prompt, change some parameters from here, do next and click on generate to create the image. This flow is a way better in looking and in terms of sharing in quality than what you would get from here. Okay, but does that mean you should directly do that? No. First, all of you should understand and do Gradio as well as you can. I know all of you are not front-end developers, but just try to get like 15-20 minutes understanding of JavaScript and React. And I will show you how I did this just with one single prompt. I'm not asking you to do this for final products. Don't vibe code it. The structure I have to write React is very different. I'm just showing this to you that you can use this for your hackathons and anything like that. So I basically just cloned the repository. It already had the Gradio app code, which Steve was showing you all. Okay. A very good way that if you're creating Gradio app for any accelerator project, just go on Cursor or whatever tools you're using. Ask it that. I will just zoom it in a little. 1 second. Yeah, that this repository uses a Gradio app for whatever project you're using. I want to create a modern design app using React. What this will do is basically it will just convert everything in React. It does it in one time. The models are really good. And later I will also share with you a more detailed prompt, which can basically more accurate, take care of security and all. But yeah, Gradio is good, and I will encourage you all to not just vibe code things. Focus on Gradio, build your apps using Gradio for testing. But whenever you are submitting it, or let's say you have to share something with a colleague, spend some time learning JavaScript and React, and just ask Cursor or Cloud Code. I will give you that prompt, and it will convert that same app for you with the same functionality with a React front end, and that will be like really, really amazing. For now, like you can again go back to focusing on this. But I had seen some people do this in the hackathons of previous cohorts, and I wanted you all to actually have an understanding that you can do that as well. Just quick note, if you build in Gradio, just go on Cursor. You can ask it to generate it in React as well. Cool. I think we can move ahead with the breakout rooms, Karthik.
All right. We'll send you into the breakout rooms. Folks, are you clear with the assignment that what is needed? Like what you need to do? Okay, Shrishti, can we give a very quick 2-minute recap of what they have to do in the assignment? Because I don't want anyone to go in breakout rooms and ask that, hey, what do we have to do?
Yeah, sure. So what we have to do is I showed everyone the pipeline function, right? How we can use the pipeline function to just about do many machine learning tasks like sentiment analysis. So that's exactly what we have to do. Use the pipeline function to classify the sentiment of a particular input. That's the first thing. Second thing is just wrap a Gradio UI around this, build a Gradio UI for that thing, just how we saw in the many examples that we covered right now, just now. That's the two things that we have to do. And I would encourage everyone to take this in steps. Do step one, then step two. Even if we are not able to do step two, doing step one is also fine.
Folks, is it clear now? Folks, I have not opened the breakout rooms yet. I'm just making sure that you don't have any questions because I don't want anyone to face issues when they go in the breakout rooms. Now I will open the breakout rooms. All right. Folks, like I mentioned, there will be around 18 to 19 participants per room. You will now, in the next few seconds, I have not opened the room yet. You will see a pop-up. You can join. Srishti, we will start joining the rooms after 5 minutes. There will be 10 rooms, so we can maybe give 2-3 minutes per room, not more than that. Because I know we said 15 minutes, but there's a high chance we'll go till 20-25 minutes. So we'll do 2-3 minutes per room. After 5 minutes, we'll start jumping. So that 5 minutes, at least they have a head start of what they have to do. They can discuss and they can start working on it. Okay. Folks, you will see a pop-up on your screen mentioning join a breakout room. Click on it. You'll go into breakout rooms. Shrikesh, Sushma, Raj, Durga, Abhishek, Ambuj, Nimesh, Tushar, Sandeep, Sarang, Madhvi, Henk, Shraddha, Ajit, Brian, Himabindu, Jasprit, MJ, Nagesh, Durga Prasad, and Bharat. Please join your breakout rooms. Srishti, after 5 minutes, no, you will see
Right.
something called as breakout room at the bottom of your Zoom.
Karthik,
Yeah,
you may want to assign me from the breakout room because I accidentally logged out and logged in.
you have
So,
1 second. Assigned. Yeah.
Is someone sharing their
Yeah,
screen?
look, is sharing screen. Let me
Okay.
share my screen.
Okay.
I can stop anyone's share screen.
Actually,
Is my screen visible now?
yes. Yeah, now I can see the breakout rooms as well on my end. It's okay.
Yeah.
Mm.
So basically, when you click on that breakout rooms, you'll see a pop-up and you can choose the breakout rooms you can go to. Same will go once you join a breakout room. You can jump. Participants cannot jump. As you're a co-host, you can jump between.
Breakout rooms. Okay.
Yeah.
So, and I have to join each one of them, right? One by one.
Yes.
Okay. How many are there? Okay, there are 10 rooms.
Then, yeah.
10 is okay. I have 30 minutes more. 10 is but yeah, nobody's. That's fine. I'm gonna do it.
Okay. So
Should I start joining, Karthik, or will you let me know?
yes, you can start.
Okay.
All right. I think everyone is back from the breakout room. Folks, how was your experience as your first breakout room? We tried to keep it as simple as possible for your first assignment so that you start getting hands-on a little bit. Sorry, a little more hands-on with AI as well. So I hope it was a good start to your hands-on experience. Don't worry. Going ahead, this is gonna get a little more and more difficult with every day that goes on. So had a great time. How many of you guys were able to complete the assignment? Shishti, you have to give them a few days. You shared the solution already with them.
Oh, okay. I thought, but it's a very simple thing. So, but yeah, I think I went to 4 to 5 rooms and everyone was doing great. And one very good thing that I liked is that people were helping each other. Like they were chatting, they were figuring out stuff that, okay, this model got downloaded. That's how you specify a custom model. So that is like great to see that spirit. It was cool.
I'm glad. So folks, what I'm going to do is quickly, I'm going to put a link over here on which you can put your questions. We'll quickly take a couple of questions, Srishti.
Yeah, sure.
Folks, this is something that I love to call Slido link. I'm going to pause the chat so that you guys can go and first put your questions there. Q&A. Yeah, I've shared it again. Please go and put your questions there. We'll start sharing my screen and showing the questions also that you guys are putting in. While we do that, folks, for the first 48 people, you might have received a notification on your GitHub repo where you might have been asked to add as a collaborator on submissions. Now, there are some people who have still added their credentials wrong over there. For them, I'll reach out personally later. Okay, while the questions come in, need to launch something. 1 second. Oh, wow. Team launched it. Thank you so much, Sham. Folks, we launched the CSAT poll as well. Basically, how did the mentor's delivery style? Were you able to enjoy today's session? Did you think the session was something new? You learned something interesting? Accordingly, please do answer. I repeat, please do not mention when you're giving written feedback, please do not give me written feedback in terms of uh, any network issues or such things that you might have faced. It should be purely on the content is what my feedback is on.
Also, I think it's important to, again, like, I don't want to mention this again and again, but I read all of the feedback, while we were waiting for people to finish in the breakout rooms. Some people they seem very upset. So, like, we have to solve that as well. I think people are not able to figure out why are we studying this, that sort of feedback. I guess there was some person, don't want to take the name, but yeah, that was there. So, Karthik, you might want to
I will answer that. Folks, I have
Okay.
0 questions coming in. Don't you guys have any questions? Or have I shared the wrong link with you folks? Okay, folks, why we are doing Gradio is very simple. So, like I mentioned it during onboarding, for people who were there on onboarding would have known about this because when I took you through the 7 sprints, I mentioned this where there very clearly that Gradio is part of a front end that we are learning for a simple reason so that we can connect it when we are building Atlas called in RAG session. It's like a second brain that you will be building. That is the reason you are learning Gradio. It's a very starting point towards your development as well. I know you must be thinking that we can use AI to code. Yes, you can use AI to code as well, but anyone can use AI to code. If you are someone who understands these things, you'll be able to code better because you understand the nuances of it. Otherwise, anyone, even a 15-year-old can code in today's time. I can use Cloud Code. I can even use it, put it on Olama and use it for free without even spending any money, and I can do it if I have a good laptop. But that does not mean that I will be a good AI native engineer or an engineer or a techie who's a specialist in AI, right? For that, you need to understand these nuances, these terminologies. Someone who's using these, especially building agents, when you're building agents with 4 or 5 different agents working together that you will do next week, you can code it using AI, but you will not be able to put some proper guardrails. You'll not be able to understand how you can make sure you're cost optimized. If you do it normally, you go ahead. Trust me, folks, you will burn money. I am saying it because I have done it. I am one of those people who has burnt dollars when I was building agents because again, I was not sure how to do it back then. Things have changed over the years, but yes. So that's the reason we are learning this. I hope that answers your question. We have a couple of questions coming in. Just give me 1 second. Uh, 1 second, just finding the link. Sorry, folks. Sometimes I get lost. I'm working with a lot of tabs. Yeah, we can quickly start with the Q&A.
Yeah. Why do we use Collab rather than any IDE like VS Code? Yeah, this is actually a pretty good question. So, what happens is that when we are on Google Colab, the speed with which the models are being downloaded, because like everyone must have seen, when we are using Hugging Face models, the green bars, the green download bars appear, right? They appear. So if we are using VS Code and if we are trying to download very big models, the speed of download is usually bottlenecked by our local internet connection, like the Wi-Fi connection at my home. With Collab, that's not the case because it's a cloud-based embedded notebook. Speed does not depend on our internet speed of download. That is why Collab. So I just wanted to make sure people know that's an option. VS Code might be too slow sometimes. Can you explain on training the model at a high level? Which tool should be used? Something about buzzword unsloth. Okay. I'm not sure if I should take this question or not because this is on the training model side. And I also saw one feedback in the chat that why are we even studying this if we are not going to learn how to train and build models? Not a question for me, a question for the fellowship people. But yeah, training a model, let me tell you, it's a pretty complex process because there is a lot of data that we need to use in order to train the models. And then for that, we also need a very solid infrastructure, first of all, lot of expensive hardware. That is why it's an expensive thing. Now, Unsloth, yes, it's pretty cool. Even I use it as part of my research, so you can definitely use it. That's how I will answer it. How do I check access to GitHub repo? Karthik will answer it. Uses of Gradio or Collab, not mentioned the session, and why so in-depth session on tool, which is just for reference. Okay, so this is a different kind of feedback. Like some people were saying, why cover theory? Now some people are saying, why cover tool in such
See,
so much
folks,
depth?
like I mentioned, this is the fifth cohort that we are running. We've taken feedbacks in the past as well. We understand what is required. I know right now you must be thinking why we are doing this. And I mentioned this on onboarding also. Two things I mentioned is that you may face some issues in the start because you will not understand how the dots are connecting. You will understand as the sessions go by. Because now, tomorrow, also, when you will be getting into this, tomorrow, a little bit in Streamlit that you will understand. You will understand more in breakout rooms also that you will do. Hands-on is required. If you want, I can directly jump into Cloud Code. I can get into Cursor. But 90% of you folks will not understand what I'm doing in Cursor right now. If you see my Olama is running, my Olama is always running, my Cloud is always running. I can start open and I can start teaching you there. But that does not mean that you will understand. You have to go from the ground to up. So there is a systematic manner. It's a ladder. It's like a, what do you say? A trek that you are doing, right? So on a trek, you can't directly just take a helicopter and go at the top. I mean, you can, but there is no fun in that and there is no learning in that. So we'll go step by step.
Yeah, so generally the thing is that Gradio is used to build UIs just to showcase your ML products or models that you're building so that you don't have to mess with building a proper production level front end. That's the use of Gradio. Collab, I've already told you, it's just a runtime notebook provided by Google, like it's a cloud-based notebook to run your Python code. And yes, okay, now we'll take that later. Will we be building our custom models on top of foundational models in future classes? Uh, I can't answer that. Logistics people will answer that.
See,
How do I?
folks, if you think we have that much of bandwidth, even you would not have your laptop also will not be able to process it. We will have to spend a lot of more money over there, which we do not have the access to. You'll be using models to build applications. You'll be using models to build workflows, but we are not building models here. That is not the point of engineering accelerator. If you're having any issues, you can connect with me personally. You can write a mail to me at karthik@outscale and sham@outscale.com. We will have a one-on-one where we'll help you understand what the curriculum talks about.
Okay. Next question. How do I check access to GitHub? Collab needs any credit? Yeah. GitHub one, Karthik will answer. For Collab, there are there are GPUs and TPUs that you can select from Collab in order to make your code go faster, but that's just for a limited amount of time. After a certain amount of usage, we will have to pay to Collab as well to be able to use it further. And that's a good question. So exited when I run Gradio function is my system, and I found code executed without any token. Yeah. Hugging Face token is not always needed. Some models are gated, and for them we need authentication via Hugging Face token, but for most of them we don't. How to know which is the best model to choose from? Is it trial and error? Mostly trial and error. Look at the benchmarks, look at the research papers, what are they saying? Benchmarks are standard data sets that you run your models through and then evaluate how are your models performing on that data set. If they are performing pretty well, you go ahead and test them further. If not, then you might need to drop them. What's the difference between GPT generated code versus writing code on our own? As long as we understand the logic. Hands-on, being hands-on. You need to be a problem solver now, not just a person who's coding, right? So be a problem solver, understand the trade-offs between, when you are building scalable architectures, those sort of things. And while GPT, Claude, Cursor, all of them are pretty great, I personally know how messy they can be. Once you give them big code bases, once you give them research code bases, they will mess everything up. Happens to me sometimes. Happened to me last time. It wrote code wherein it missed just a single line, and all the logic was flawed because of it. All the labels were flawed, research signal completely flawed. So you have to be very quick in reviewing the code, checking the code, making sure the generated logic is right. I think that's the key skill that's needed now. And this is a good question. Why Google Colab explained? Again, explain how to choose a model. I think I just explained it in a previous question, so that's also done. How do I know which model is better? Is there a scoring? Can I tune the model with hyperparameter? Say, okay, hyperparameter tuning happens when you are training models, not when you are inferencing from the models, but a good doubt, it's cleared now. How do I select the best model for sentiment analysis? Generally, just how you would select the best model for any task, use benchmarks, try and test them out, and yeah, that's how you would do it. Can you tell me a real use case where the Hugging Face model was tested, checked via Gradio, and a product was built? I can't speak for industry, but academic labs frequently showcase their models via Gradio. Go to Hugging Face spaces, you will find a couple of interesting spaces over there. Do we have any model, do you know, that should work for anything like a god? Generalist models, strong reasoning models, Opus is there, GPT, this 5.4, the newer models, they are pretty good at solving complex things like code and math logic. Literally, we have just LLMs gave the code, just we ran it, nothing installed. Do we need to install other than Colab? In Google Colab, it's something very isolated, not interfering with your system installations and dependencies. So with Colab, yeah, just install things in there and then run them over there. Need step-by-step instructions to write the code and jump across toolings. While discussed in the running session, couldn't replicate during the breakout. No worries, I've shared the solution with you. Try to interact with your peers, try to maybe just review the session recording and you will be able to understand. Why Gradio? Why not Streamlit? Gradio is more for ML use cases and a part of Hugging Face, so covered Gradio today. Streamlit, I'm not sure if it's there in the future sessions or not, but yeah, we'll see. Model is a mathematical function and we use mathematical processes used to define how models get. This is confusing. Okay, this is confusing. But then people were saying we don't need theory. So now what do I do? This is my dilemma, but I'm going to answer you. So what happens is you would define a model architecture. That model architecture is just like a skeleton, good for nothing right now. It does not have any knowledge of the data that you want it to be good at. And then you take your data, all the data from the internet, your code data, math data, physics, biology, chemistry, mathematics. You train your model on that data using algorithms. Backpropagation is there, gradient descent, all of those things. Those are algorithms. That's how you train the model over time. Keep training it for a couple of days, maybe weeks. And that's how the models get better. Once they are fully trained, you just use them. That's how it happens. Collab Radio be installed inside yeah, VS Code. Collab can now work inside VS Code. Yes, the integration is there. We can do that. Could you provide an explanation of transformers and layers along with a few examples? Okay. Yeah, I can do that. So transformer is just a type of architecture, just a type of machine learning model architecture. Examples. So, GPT-2, it's a decoder only transformer. T5 is a model, it's an encoder decoder transformer. So these are the examples. And more theory, I think more theory is not what you want. So yeah.
All right. I have only one question. That is, why did you ask about if you want to have Google Colab in VS Code? Why do you want Colab in VS Code? No, that's my question, Shrishti. I was not reading any charts. For someone asked, the
Yeah.
Colab radio can be in VS Code.
Yeah. Yeah, it's like
Fine,
because we have terminal access over there. So just because people are
fine.
working it. Yeah. But okay, I think this is it. Any other questions, anything, feel free to ask.
Folks, training is something that we are not talking about right now. Maybe if you want to understand more of training models and fine tuning, we'll take it up after you have gone through a lot of more sessions and we can discuss this with Sid.
Yeah, and just one real life, like real world use case I can share with you. There are a lot of problems that can be solved via machine learning, problems that people aren't even thinking about. They're building companies, building startups, solving them, and really earning millions out there. That's what people are doing. And they're not training or fine tuning their own models. That's not the first place where they look at. Why? Because companies like OpenAI and Anthropic, they exist for this purpose. They're like, we are training, you solve use cases using these models. Why do you want to spend so much money in training your models? Because training is not like, yeah, training is fancy. You need a team of researchers, you need a team of infra engineers, performance engineers to be able to do it reliably. So it's a complex thing, and it does sound fancy, but once you get into it, you yourself want to get out of it. You're like, give us the model, we want to build products using them.
Also, folks, when you talk about training or fine tuning, there are two reasons that I never recommend. Firstly, use cases that are there, around 98-99% of the use case can be solved with the already existing models that are available. You can basically use their RAGs if you want to do it based on your own data. That is one. Second thing, fine tuning does not confirm correct answer. Any mistake that you've made can lead up to big issues. Third, when you're working in large organizations, when your data keeps on changing, you cannot keep training a model, because if you keep doing that, that is super duper expensive. And if you have that much kind of money, you can always send it to me. I will give you my bank account, but that is super expensive. That is not something that we recommend at all. So yes, it may sound fancy to you that, hey, I'm fine tuning a model, I'm training a model. That is not something that is required unless you are getting more deeper into machine learning and research, like Srishti is been doing since couple of years. So unless you're not getting into that, trust me, this topic is not something that would be required, relevant for you for years and years to come.
Yeah, and just one more thing. So, for us as mentors and for people who are organizing the fellowship, we have to make sure that we are targeting a very general sort of audience. Because, some people are asking theory specific questions. I really appreciate. Some people are like, why are you even touching upon theory? Go directly to why Gradio, why this and that. Go directly to what matters, which is what the hype train, the agents, and all of that. Both sentiments I really understand. Even like if I were in your place, maybe I would also have been one of the teams. But the thing is, for us, we have to cater to a general audience, right? So we have to cover a little bit of theory as well, a little bit of, and like more on the practical side as well. So whenever I say that, skip this, we can't do this, it's not because I don't know it. I can teach you anything that you want me to teach, but you see, we have to cater a general audience. That is why we do it. But yeah, all good. Like every kind of feedback is welcome. Even if someone is angry, I could see somebody in the chat was very angry. It's okay. You can be angry. It's fine. Just let us know and we'll solve your doubt. So it's all good. Everybody gets angry sometimes.
All right. Awesome. Thank you so much, Srishti, for a wonderful session. Folks, today I am leaving you on time or a little maybe before time, 10 minutes before time. Because going ahead, there will be days where I'll leave you again late. So today I thought I'll let you go a little on time. Thank you so much, Srishti, for a wonderful session and taking this up in the last minute. It was a great session. Really enjoyed it. took a very different perspective of this session as well. So great having you here. Guys, we'll see Shrishti once again next week on Tuesday, exactly next week. We'll see. 31st. All right. Thank you so much, Shrishti.
Yeah, thank you. Thanks, everyone. See you. Bye-bye.
All right. Folks who are asking where they will find GitHub notifications. 1 second. Very best George. Okay, yeah. Share screen, share. You go on GitHub. Sorry. Click on notifications here. Okay. You see this at the top right, just besides the navigation menu, there's something called as notifications. Click on the notifications, you will find one. Okay, or if not, you can just refresh 1-2 times. If you've not received, that is because you are not in the top. You were not in the first 50 that have shared their GitHub credentials. For people, please do not DM me your credentials on the chat. I will not be taking it one by one. Fill it in the form. By chance, you're not able to find the notifications menu. Sometimes for few people who are new on GitHub, they're not able to find that notification menu. Just go on this link. Just go on github.com/notifications. As simple as that. The latest PPT. Where do you find the form? It's there in your WhatsApp description, WhatsApp community description. Yeah, Sham, let's upload the updated one that Srishti has shared, the deck, in the start of the session. We will upload that. I am sending it to you on DM. Yeah, we can upload this.
Yeah, Karthik, it's already uploaded.
Yeah. Oh, wow. Awesome. Already uploaded. Folks, so we block your timings till 11 p.m. The reason is because sometimes the session goes a little longer. Like yesterday, we went up to 11:30. That was half an hour was the extra bonus that Siddharth wanted to share with you folks. That's why he went a little over and above. He's someone who loves to talk about AI, so he loves to give more and more information to learners. He's very passionate about it. So the session timings actually start from 7 to 10:30, but we block your calendar till 11 so that it is not, you don't feel that, hey, you're blocked until 10:30, it's going on till 11, I'm facing any issues, or such issues are there. That's why I block it till 11. Prashant, it is there in the description. It is not shared in the message. You can click on the top of WhatsApp. It will give you the description of the community. Click on it. You will find the link. If you can't see GitHub notification, that is fine because GitHub only allows me to send to 50 collaborator in a particular day. Over that, it does not allow me. Sorry, I cannot do anything over there. That is GitHub. You can take it up with GitHub. We are 200 people, so it will take me 3 to 4 days to get it to everyone. If you've not received the notification, that means that you are not in the first 50 who filled the form. You will receive it tomorrow or day after or the day after that. 200 people, 4 days, 50 per day. I hope that answers the question. Yes, so for folks who already have gotten access, please save your assignments. For people who have not received the access, save your assignment and keep later on. You can submit those assignments as well. How to submit it? Take the collab, just paste it in a README file on GitHub. If you just provide the GitHub credential, you receive it in a day or two. If you need any issues, there is something called as Ask Doubts on LMS. You can go on Ask Doubts and post it over there. If by chance I am busy or Sham is busy with other things, your fellow teammates can also help you. Folks, you can also go on LMS and go on Ask Doubts and see what your fellow, not teammates, your fellow peers have asked. You can also help them out. Folks, if you fill the if the form, don't worry, you will get the access. There is no, I am not running anyway. I am here with you for the next 14 days. You will get the access. Don't worry, I'm here. Where can you find the WhatsApp community link? Okay, sure. Let me show once again. Where did it go? 1 second. Yeah, I'll share my screen, share screen. You see, whenever you log in, the first thing you see is welcome and next steps. On the left-hand side, welcome and next steps. Scroll down, see more. Click on see more. Again, scroll down, join WhatsApp community. I hope that helps. Welcome next step. Scroll down, see more. Scroll down, WhatsApp community. We don't have N10 tomorrow. N10 is day after, first of all. And you don't need paid models. You can get 14 days free trial access of N10 as well. You can use that. By chance, if you want, you can also locally host N10. How do you locally host N10 is N10 themselves have put their repo on. You can go and search. Or second thing that I love to do, I will show you. Give me 1 second. Let me put my laptop on charge. Otherwise, I will drop off. Give me 1 second. I'll show you something that I really, really enjoyed. Yeah. And which is so simple. You'll laugh if I'll show you. One second, I'm just setting it up. Yeah. Yeah. For people who want to know about N10, it will be day after. It's an automation tool. You can locally host N10. Like I host N10 locally. If you see over here, for me, it is locally hosted. Okay. I make a lot of new things just for fun. Yeah. So I am a 10-year-old who is trying to locally host N10. I need your help. Wait, what happened now? Your help in what to put in the terminal. Please give it step by step in a way I can copy paste. I am using a Mac laptop. Step 1, open terminal. Press this, and this. Install this. Install this. Checked if it worked. Install N10. Start N10. Open in browser. I know it sounds so simple and it's laughable, but yes, that is how I installed N10. Bye. Okay. Anything else, folks? When do you get the open router key? You'll receive it in the mail tomorrow. Because before tomorrow, you did not require open router keys, so I did not create your open router keys. No, N10 is not an alternative to HuggingFace. N10 is an automation tool. It's used for automation. HuggingFace is an open source platform where there are a lot of models available. So it is not at all related at all. WhatsApp, folks, as soon as you log in, welcome and next steps will be on the left-hand side. Click on it, scroll down, see more, click on it, scroll down, WhatsApp community. Okay, guys, let's take it slowly. From where I didn't follow what is being discussed on GitHub. Ram, so there will be two GitHub repos that we will be sharing. One will be called submission_C5. That is where you will submit your assignments. Your collaboration access you will receive in the next 2 to 3 days. How to fill the GitHub form, that you can go on the WhatsApp community, go on the description. There is a form over there. Just fill that form. When you fill that, we will get your credentials and then we will give you collaboration access. Second is called AI Accelerator C5. That is where I will upload all the codes, whatever is taught in a particular session, and give it to you. I hope that answers it. For any content that is shared in the chat, for any links that is shared in the chat, is also there in the recording. As in, when you open the recording, resources and recordings, go on day 1. If you scroll down below the recordings, you will find all the links that are there. If you want, I'll show you that also. Give me 1 second. Share screen. Resources and recordings. Start again. Results. Session recordings. Day 1. Click. Scroll, prompting guide, GitHub OpenAI, Excalibur link, JSON prompt, structured output guide, papered on system prompts. I hope that helps. No, you don't have any other assignment as of now. Sure, Venkat, I will pass on the message to Circle for this. I'll ask the platform guys to highlight. See. Gayatri, if possible, if you're facing any issues, if you think it is different, write a mail to karthik@outskill.com along with sham@outskill.com. Just write a mail to us and I'll help you out. Transcript access, I don't think so you guys have. Sham, do they have transcription access?
Not of the chat though.
Okay.
Zoom is allowed to in the chat transcript.
Yeah. I was very fast. Vijayaraj, about what? Could you elaborate about what do you want me to show again? Yeah, folks, by the way, we are done for the day. I'm not teaching anything new. I'm just solving few doubts that you guys may have regarding LMS or GitHub. That's it. Sure, Ravikant, I will talk to the team. Sham, if we can take these feedbacks for the welcome and next steps pages, we can see if we can split it or rather we can highlight the see more option.
Yeah, sure.
Where do I get so much patience? Not sure. It's just who I am. Tomorrow's pre-reads are uploaded. Sham, please also put the same message on WhatsApp as well for people who have dropped off. Even they can get it. All the resources you already have, Prasad. Why do you want to wait for after the course is ended? You already have it now. So you can go and check out. Collab, you don't need to download. Collab, you can just go and log in. You don't need to download Collab. All right, folks, that marks the end for today as well. Thank you so much for joining in today. I'll see all of you guys tomorrow at 7 p.m. IST once again. Till that time, take care. Good night, good morning, good afternoon, good evening, depending from where you guys are joining in. Take care. Bye, folks. Praveen, pre-reads is basically something that we provide before the session that you can have a read through so that when you are getting into the session, you already know what you're going to read or learn.